All right, welcome everybody. Tonight is the 27th of April in 2021, and here we have the Dallas Personal Robotics Group Builders Night Virtual. We'll do the usual thing we do, go around the table and follow up on each other's projects and take questions from the crowd and try and generate cool answers, useful answers, or at least distracting, amusing answers for Stump the Club questions. So basically, my name is Carl Ott, current president of the club, and I'll just serve as a moderator here. We're going to start off tonight with Doug D, and then we'll switch around to Ted, and then we'll duke it out for who's next. So Doug, take it away.
Okay, so I wanted to show my telepresence robot again, and I was hoping that Chris was online. I see that he's just got his picture, and my dog is desperate to attack the robot. So let's see if we can pull this off. Are you there, Chris?
Yeah, I'm listening.
Can you open up your viewer and try to control my robot again?
Actually, I'm on my phone right now. I'm not on my laptop trying to find it, actually. So
yeah,
but I'll have it in a moment.
Okay. What I found is that I've tried several times controlling it over the internet from Starbucks, a pretty weak Wi-Fi, and it behaves quite well. And what I've noticed is that my Wi-Fi at my house seriously deteriorates around 9 o'clock or so. And I think that's the trouble we were having, which is a good point to keep in track for when we actually go live and we're at the makerspace. And I don't know what their Wi-Fi is like, but if anybody else wants to try, I don't know if anybody else has got the viewer downloaded. I know David tried last week, but I don't think he was in the viewer. I think he was in the server. That's why he was getting the response he was getting. Has anybody else got the viewer loaded?
Let me try again. If you'll talk me through it, let me try again.
Okay. Well, you have to have downloaded the VNC viewer, not the VNC that's comes preloaded on things.
I have Tiger VNC on my Linux machine.
Yeah, that's probably the VNC. You can control your Linux, but not control something else.
No,
that's why when you tried to log in, you were getting that response you got.
I think the reason I wasn't working was because it by default attempts to connect through a secure shell tunnel.
Ah, okay.
Okay, so but I can disable that.
Okay.
So,
well, Tiger VNC is not going to want to talk to the real VNC, cloud service, I suspect, right? Because at that point, you are not just doing standard VNC stuff. You really need to be able to talk to their server, which is proprietary.
Do you know what the port number is?
No.
See, it's not standard VNC at this point anymore, right? Because you're going through a middleman in the cloud, right? So it's not standard VNC from a client to any random server. If you have a point-to-point connection, any random server will talk to any random client. But this is proprietary, real VNC stuff that he's doing.
Right. So probably that's not going to work for you. So I can wait until Chris comes online then to demonstrate what I wanted to demonstrate.
So yeah, let me fire it up.
Yeah. Ted had something he wanted to talk about.
I don't know if I still logged in, right? So you gave us the username and password last time, so I don't know.
Right, and I have not changed them.
Oh, okay. So we can just log in to
support@myrobotblogs.com.
Okay.
And
all right.
And then the password is remote computer camel cased, capital remote, capital computer 01.
Got that. I got this.
I didn't take the support@myrobotblogs or blog.
Oh, they need to check that it's me. So it sent an email to support@myrobotblog.com.
Lost my connection to you guys.
You're frozen.
Okay, I got a different response this time. It says connection refused.
Yeah, it'll only work with the real VNC viewer because you got to actually sign into their cloud service first.
Really?
Doug, I'm trying to sign in right now. I created an account and I'm looking to sign in if it's possible.
So you're telling me this fancy machine I have here with this late model Linux running on it and a Tiger VNC viewer with all that fancy technology, I can't connect to your machine?
You need if you can manage I don't know. Real VNC must have a viewer for Linux because they have one for the Raspberry Pi.
It does.
If you install that on your super fancy machine, then you can do it.
Right.
It's all one word, Real VNC?
Yeah, and I have a link in my, let me get over here.
A great branding name, Real VNC, because that means that all the other ones aren't real.
Chris, is that all one word, Real VNC viewer?
It should be. Well,
I don't know. I think I've only ever known it was Real VNC, and then Type VNC came along sometime afterwards. So
yeah,
I really don't know what all that real word is in there. What it means.
realvnc.com is their website, and then once you're there,
I put a link in the chat.
yeah.
Oh, good.
Download
We're
link.
just trying to do that.
support@myrobotblog.com, right? Is that
Right.
Did I have that right? And then
Yes.
remote computer
Remote
01.
Remote capitalized, computer capitalized, 01.
Yeah, it's not,
But Doug, you need to check that email because
I'm working on it.
Oh, I see. Okay.
I
It's,
seem to be typing in the wrong username and password because it's not even letting me.
Here we go. Here we go.
Check mark. No.
Press sign in.
Oh, there we go. Okay, I'm in.
You should see a screen that has a camera view and buttons once you get in.
Oh, I know how to get in. Yeah, I use this all the time. I'm there.
Well, click on the forward button, see what happens. There
I just turned it right, left. You're in trouble now. There's left again. We're going to spin around here.
How's your response? Click the button and you see the camera move?
It's pretty good.
Yeah. See,
And I guess the response from the puppy dog is pretty good too.
Yeah, the dog is after it. I found good
sure.
response, except late at night, and that's what I think that Chris was having trouble with.
So here's, everyone should be able to see my screen now. Yeah, so I click right.
Yeah. So that's the delay over the real VNC as well as over your presented.
Yeah, my network. Well, I have a pretty fast network. Or I'm going to go towards the car just because he won't like it.
I'll be right back.
Show us the dog.
Seems like Doug's dog and his robot hop.
Oh.
I think Carl's about to become dog food, man. I think virtual dog food, anyways. That's what you can do. You can put a little thing on there. You can put some things on there so it kicks out some kibble, and
Yeah.
then the dog is going to be all about that, man.
Uh-oh. I got it stuck now.
Trying to go out the door, eh?
I thought I'd chase after the dog.
Having trouble getting over that bump.
Yeah, it's a little stuck on the transition.
So this is the prototype.
No, it's a good
Not
response.
good for driving. But you're back to active again. So,
Oh, shit.
I'm feeling good about the overall prospects of using real VNC, and I'm trying to. What you see is that I have a drive method at the top, which is not yet activated, based on the feedback that I got from Chris last week.
You just
And right now, it's stepped is the only one that works.
Doug, your audio just faded away.
Yeah, I'm not surprised. I got all this stuff going on
Mouth
here.
is moving, but no sounds do we hear.
That's interesting because I'm not muted.
I can hear Doug.
Probably because Chris is presenting.
Yeah. No, it does. It drives pretty well like this. So
Yeah.
I mean,
Now you
from
just need to have the servo to get the camera to go up and
Yeah, I
down.
don't have that button yet activated. I haven't put the servos on to accomplish that on this computer.
What's the delay, Carl? Can you stop? Stop watch
okay,
it.
so
Yeah,
click,
I was able to drive
click,
around without any problem, bumping
click,
into things. So
click, 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 click. Yeah, you can actually see if you watch the button, you'll see the press action in the UI, and it's responsive enough for driving. I mean, but I think as again the interesting part will have obstacle avoidance and say,
Right.
oh, go over here. I want you to park here and turn around or something like
Right.
that. That'll be the fun
Yeah.
challenge.
So behaviors will be what I do soon. I've been working on right now activating that drive method, and then once I'm done with that, I'm working on getting Roby Senior to move with this as the driving UI, which will demonstrate that they both behave with the same API, which was
Nice.
there.
Yeah.
And I have to get Robbie back to operational, which hopefully, I'm going to be gone again this week, so I don't know if I'll have it done in time for next week, but soon. And then I'll work on behaviors.
Yep. No fun when life gets in the way, but that's right.
I know. So, Chris, were you live? Were you able to control?
Now I somehow again either I picked up your email wrong. Support at myrobotblog.com, right? And remote
Right.
computer 01. It's not.
Blogs. My robot blogs with an S plural.
Okay. All right.
And remote is capitalized and computer is capitalized.
Right.
01.
Okay. I think now we yes. Okay. That's
Okay.
better.
Carl could stop and let him. I want to see.
All right. Now we're in business.
I'll get out.
that's
There, it's all yours.
It shouldn't
All right.
matter.
So
if
now
you
you want me to get up my stopwatch and give you some
Yeah, I want
feedback
to
here?
see if your response is any better this time.
And I want to see if I can
Oh,
get
and-
back to my original login without losing anything.
What was the password into the Pi?
Oh, the password into the Pi is, hold on, I have it here. I think it's DPRG guest.
1. You want
Right.
to paste it?
All lowercase?
Yeah, DPRG, all capital, guest, capitalized, and then 1.
Okay, got it. I'm in.
Okay.
All
so
right.
Click some buttons.
Okay, now I'm gonna pull up my stopwatch here. All right, so we're gonna go forward. Okay. Wow, that was
Much better than last time.
yeah. I can barely hit the stop button on the stopwatch in time. So yeah, that was pretty good.
Yeah, so I think it was internet load or whatever you call it was the problem last time. Because I
Yeah,
haven't modified the code. At
but
least
so
not in
that's just the thing, right? I mean, and I've seen this even on my local Wi-Fi. If I'm just trying to stream locally,
Right.
I don't always get the same performance even on my,
Right.
network. And so that's just one of these things that you can't control, right?
Right. So we may
That's
have to
the thing
live with that.
you can't count on having a perfect connection.
I'm going to go dark for just a second.
So for all this interactive stuff, we kind of need a real rock solid connection, but it's no guarantee you're going to have it when you need it.
Yes, and we'll just have to see how that works for us. But I'm feeling good about the overall prospect of the system.
Well, the only thing I guess would be, so this is for interactive kind of thing, right?
Right.
You just have to sort of then, okay, so who would own that account, or would DPRG have a real VNC account and so on? I mean, how would that be managed?
Yeah, my plan there is that there would be, like I use DPRG Guest One, the DPRG would own some email accounts, and I would assume that they would have those instead of support@myrobotblogs.com. I don't know if that's capable, and y'all can certainly speak up and say if y'all have multiple accounts, you can donate to that. But the plan would be that there would be one account with one robot attached to it, and then when people were remote, such as you and Pat and there's 3 or 4 people here that are remote, y'all would just say, I want to be on one of the robots, and we would say, okay, use number 1, use number 2, and then that way y'all would have control of that robot, and I think that would make it work. So it'd be an assignment type thing for each meeting.
And what about audio? Would sort of Google Meets be also running then on
Yes.
this robot separately? Or?
You'd have to have like a phone or a tablet attached on a pole or something, running Google Meets or running Zoom or running whatever that Microsoft thing is. And I was thinking if we did this Google Meets, multiple people could be on there. Just try not to interfere with each other driving, because there's not a problem with having multiple people on the Pi, on the real VNC with the same thing. You just have to be nice to each other pushing buttons.
Okay, I'm trying to do this and it doesn't seem to find support at myrobotblogs.com.
Did you download the viewer?
Yep.
And you're doing sign on? And it's robot blogs, plural.
Right, got that. Yeah.
I'm going to put this in the chat. At some point, I'm going to probably take these and change this password. Right now, I just turn it off. So there's the email. There's the password. If you need it. If you could ask the Pi's password, there's its password.
You probably mentioned this previously, but I forgot. What did you use to create this GUI? Is that Python?
The GUI is created with tkinter, which is it comes with Python. It's built in.
Okay.
It's a relatively simple. It's sort of HTML-like in the way it looks. And I can pop open.
Yeah, and now I realize I see the IDE open here. But that's one of the disadvantages of this, right? Of VNC, I can really mess up this Pi right now if I wanted to.
Oh yeah, you have control. And there's probably ways to stop that, but since I'm only letting people I trust in, and I know who you are, I'll come look for you.
Well,
you know where to find me.
Know who he is.
So on the screen here, you can see.
Stresses.
You can see the way tkinter looks. You define labels or widgets, and then that ends up being on the screen.
Right.
But the thing is that if multiple ones of us are logged in at once, you won't know which one of us loaded the virus that drains your bank account.
Well, I was thinking about that very thing today before the meeting, and I was Googling around, and those Linux guys are saying we don't have viruses. And we'll see. I've only just started looking.
Yeah, that's a challenge.
but you are in my cloud, and you probably could sneak around if you knew how to do networking stuff. So security is a thing we need to consider. I'm going to stop presenting.
I'm trying to sign in now, Doug.
Are you?
What's
have
that?
I'm trying to sign in now on your account.
Oh, I probably need to look over at my email.
Can you hear me?
Yes.
Yes.
Yeah, I've recently explored a little bit of that with Raspberry Pi about security. Is one of the things you probably want to do is to remove the default Pi account if you haven't already, and just use a completely different account with root privileges.
Now, what I did,
Have you?
I did. I changed the password. I didn't remove it.
Oh no, yeah, that's the thing is if anybody is fishing around and gets in, and they try to get into your Pi, they'll try the default account that comes with the default. If you go to the raspberrypi.org, they'll have plenty of tips like that for improving your security.
Okay.
I just did it on my Pi 4.
Yeah, good tip then.
Yeah, but the thing is, Doug, if the Pi itself is not exposed to the internet,
Right.
Meaning all you're doing is sending HTTP traffic or this kind of traffic up to a third-party cloud service, can't no one outside that network hit that anyway?
Well,
Yeah,
but I'm on his Pi, right? I can open up a shell here.
Yeah, but because you're on his Pi because he gave you a password to get in through his VNC that goes over a tunnel to get back into your Pi. You're just not anyone on the internet. It's not like somebody can just drop by and hack you.
That's true.
No, I just
be friends.
There's a lot of stuff in the way. There's a lot of locked doors in the way.
I'm sure VNC has done some work on that.
Well, as a little anecdote, while I was setting up my Raspberry Pi 4, and I had installed a web server on it, and I started out at port 80, and I switched that to a different port. But within 30 seconds of being on the internet, I detected an attack on the Pi that was unsuccessful. So people are probing. If you go to a web page, people are probing port 80 all the time.
So your local network is attached directly to the internet and is not hacked up then.
Right. It's not the same thing.
Doug is behind a NAT. He's behind a firewall.
Right. I just thought it'd be useful information for anybody who's kind of doing the same thing or something similar.
Yeah.
Yeah. So I mean, it's not on the internet directly, but if the thing with you have password security here, so if somehow the password leaks out, right, to this VNC account, you won't even know that it has leaked out, right? At that point, someone could just log in.
Right.
So which one of the 4 people you give the password to already going to leak it out, Doug? That's what you need.
Well, it's also on this video, which is posted on the internet. So for the real passwords, we probably should do that.
That's a whole different problem, right?
I think Chris did it. It wasn't me. Nope.
But for right now, I'm going to go with turning off the power when I don't want you to drive it. Makes it real hard to hack.
That's a good one. Also, you might want to change the passwords on all those things since this has been recorded through this YouTube video that's going to be up there.
Right.
So
I specifically chose those as throwaway passwords.
That's a good thing.
Represented.
It's a wonderful, wonderful, wonderful thing.
Yes. So I guess I can let go unless somebody else has some more questions, and let somebody else have the floor. Feel free to continue to drive my bot.
Doug, I think I just shut down your script.
Oh, really?
Yep. While I was trying to get out of your window.
It started already.
Exactly.
It says it's still running.
Okay.
And it's not even a virus. It's just fat fingers.
And I can still drive it.
I don't know, man. I'm thinking Chris is a virus just by his very nature. I'm just saying. See, Murray, I'm not picking on you today. So I'm just trying to give you a little relief.
Yeah, those Yankees, huh?
Yeah.
Just
right now, I'm the only one that's remoted to the Pi.
I used to run the Turing test on him.
Okay. Well, Doug, looking good.
Yes.
You're forging ahead. So that's.
So the next step is sometime, I guess, if you want to try it from the actual maker space. Because right now, they do have limited number of people, and as long as you wear a mask, that's the only real catch. Tonight
We
they
might have to get
are
together and
probably
do
using
that.
the room. So yeah, if you went to Halloween, you want to get together and test it out more.
It's interesting that I have only been in this club while it's been with
Virtual?
virtual meetings. I've never been to the makerspace.
I thought you had been one time or another. Okay. In any case,
We'll
Halloween
get you a tour.
ready.
I went to the makerspace, I think like 7 years ago once. And
Well,
it's kind of cool. I want to go back.
it's changed since then. We're in the third building, I think.
And
if
it's
I
a little
remember
bit
right.
bigger.
Yeah, slightly.
Yeah, 5 times or something.
I'm going to step away for a minute and release the Krakens. AKA.
All right.
Yes.
Okay, so I think Ted, you were next in line. What you got?
Can't hear you.
We can see you though.
You're not still muted. Nope. Well,
No,
Must
it's
be your
telepathy's
headset.
not
Not
working.
plugged in. It's not plugged in.
Mute button or a switch or a. Maybe you need David's laptop. His super powerful computer.
The double mute somewhere. Double mute.
Yeah, okay. Is this
There
better?
you go.
Yes,
There
yes,
we go.
yes.
Yeah, okay. I had a USB device plugged in that was interfering with it. All right, then. Yeah, so I'm getting excited. My outdoor rover is moving now. I've got it
Cool.
working. I've got these rails that I got from, what's it called? Go Builda, which is basically Servo City. Anyway, so I can move the wheels to different spots on the rails. And so I was experimenting with just the wheelbase, and I started out with the wheels all the way out, which was a little too far, and moved them in until it started to turn better. So I've got a video that I'd show here. I'll present here. Let's see, window. There we go. And share that. And are you guys seeing it?
Yeah.
All right. So this is with the long wheelbase. It still turned, but the turn was kind of jerky, and it took a lot of power to get it to turn.
Are you controlling that with IR or Bluetooth or what?
This is just a radio control transmitter. And
You mean standard remote control car kind of thing?
yeah, exactly. It's actually an airplane transmitter, but let's see. Right. So that was the long wheelbase. That was, I think, about 2 inches longer than the track width. So here it is with the shorter wheelbase, and that one's turning a lot better. So this wheelbase, I think it was about a couple of inches shorter than the track width. So yeah, it turns out there's a reason they have the reason why skid steer vehicles have a short wheelbase, because it just makes it turn a lot easier if you think about the just the dynamics of the whole thing. And
Isn't the rule of thumb it should be square?
Yeah, somewhere square. If the wheelbase is shorter than the track width, it works fairly well. You know, the longer the track width is, the better it turns.
Longer the track width.
So the track width is how far apart the wheels are, and or how wide apart, and then so let's see if I can. Oh, this thing's heavy.
Between the tracks, I guess.
This is the track width here, and this is the wheel base from one wheel to the next on the same side of the car. So if the wheels on the same side are close together, and that makes it just turns better if you think about it. If they were exactly the same, if the distance between the wheels was 0, you'd basically have a 2-wheel vehicle, and then it would turn really well.
Yeah.
Usually they use the term wheelbase, though, between the distance between the 2 wheels, not the front to back wheel, but across.
Well, that's the width, the track.
Well, it's usually the word wheelbase is used for that.
I'm gonna Google that.
You can,
I agree.
if you look up differential
Front wheel,
drive,
the back wheel.
if you look up differential drive and you go into the XY navigation, you'll see that wheelbase is
Oh, this is interesting.
something like
In Wikipedia,
XY
actually.
divided by wheelbase.
What does Wikipedia say?
Wikipedia though says wheelbase is from front to back and track is from left to right. So there seems to
You're
be
right
some.
then, but like I say, we never use that terminology. It's always.
I agree with you. I'm also used to what you are saying. It's just that apparently Wikipedia and probably others think of it the other way for a 4-wheel drive vehicle at least.
It's going to be really confusing to a lot of people when they try to follow the math examples that are out there. So just be aware of it, Ted.
Yeah, okay.
Yeah.
And the other thing I wanted to bring up is, I was thinking of ways to give myself a little more ground clearance. And obviously the best way is probably just to put on a bigger wheel. But I thought maybe, if I cantered the wheels so they're coming down at an angle, that might help.
No, that's going to be less, isn't it?
Well, I mean, if I push the middle up, then I'll give myself more ground clearance.
You have your motors attached to the wheels.
There's
so the wheels.
a kit out there that does just that sort of thing. Let me see if I can look it up real fast.
Yeah. So right now I have the wheels directly connected to the motors. The motor shaft just goes onto the wheel, which works. It's just the because of the width of the motor and everything, it doesn't give me a whole lot of ground clearance. It was enough to move around in my grass, but be nice to have a little more in case I'm going over rocks or something.
I can tell you from my own experience that which I'm using I used a 10th scale, which I think the wheels are about this big, and it was able to do the course, but it was I would consider it marginal.
Okay, yeah, that's good to know. I think these wheels are 5 3/4 inches in diameter, so they're pretty good size. But yeah. But anyways, thinking about this, I thought of just looking stuff up online. I found some people use hub motors where the motor's actually inside the wheel, inside the hub. And I found there are some people using, what do you call them? Hoverboard wheels. And Murray, you might be interested in this because it looked like something you could mount onto your rover.
Yeah, thanks, Ted. That's exactly what I'm looking for. In fact, when I get to describe what I've been doing, that's literally what I'm trying to figure out is finding something like that. So I'll just Google hoverboard wheel.
Yeah. And they're fairly inexpensive. I think they're around $40, $50. And they are, we call it brushless, which I just usually use brush motors because they're simpler and the wiring's easier. But for what you want, it might actually work out better. And hoverboards have a lot of torque just because they have to hold someone up. So it seems like a good match.
The only downside is actually the scale of my robot is probably smaller than the ones I'm seeing here because these are designed to carry a human, so they need a bigger battery, etc. So the scale of the robot's like about half this big.
Okay, yeah, that might be a problem.
Yeah.
Who's playing clarinet?
Oh, that's my son. He's practicing.
I picked it out.
Yeah, pretty good.
Ted, I do have just a comment, a simple comment about your geometry question. And that is, let me see, can I present a video here? What do I do?
Sure. There's the present now button in the bottom right.
Did that do anything?
Yep, you're coming up.
All right. Is there a video there?
Yep.
Indeed.
Okay, if you look at JBot, this is made out of RC car suspension parts. It looks like it's long and thin, but in point of fact, it's square. If you measure from the center of the front wheel to the center of the back wheel, that's 18 inches. And if you measure from the center of either wheel to the center of the opposing wheel, that's also 18 inches. So while this looks like it's long and thin, it's actually square. And but this is a 6-wheel design, and I use the independent suspension for the very reasons you were talking about. But if you watch it spin in place here.
9 April 2005.
Yeah. What you can see is that the center wheels, let me rephrase this. The front and rear wheels are scrubbing sideways, which takes an enormous amount of torque, as you pointed out. But the center wheels are actually rotating around a circle, just like a 2-wheel differential drive.
9 April 2005.
Yes. You guys keep hearing, can you hear the audio?
Yes.
Yeah.
Okay. Last week there wasn't any audio, so I don't know what the difference is. I can mute it here. Does that do anything?
Yeah, probably would. Now we just hear your voice.
Okay. Well, you see those center wheels are describing an arc, the circle. They're not scrubbing sideways. And the front and the rear ones are. But even in this case, as I say, because the whole thing is square, if you look at, like those little front loaders, little skid steer front loaders, the wheels, them are almost right next to each other in order for them to get that tight turning radius. But at any rate, my experience has been the square works out well. And I'm done.
Although, David, you should point out though that does require that the weight on your robot is balanced.
It helps if you have equal weight on every wheel, but I think that's a general truism about all robots.
Right. And what I found from moving my wheels around was the closer they are together, front to back, the better it turns. There's kind of a trade-off because I'd like them to be further apart just for stability and having more area for mounting and putting stuff.
Let's see if I can hang on a second. Let me try to present again. I'm getting better at this.
But yeah, I found somewhere close to square works well.
Yeah, I just posted a link up there from Servo City about that Acrobotics I was talking. They called it the 6-wheel drive Mantis. So I think this is some sort of the design you were kind of going for, where the center is raised, and so it gives you the upper ground clearance.
Oh, come on now, that's the design. Do you have a picture on your screen now? I can't tell.
Yes.
It's a very classy looking picture.
Somebody took that at a DPRG meeting. But what you can see here is that these are from a RC chassis, and we built the chassis and we took their suspension. And these wheels go up and down about 6 inches. They have an enormous amount of throw.
Oh, wow.
And I can show you some videos, but I really, the guy I worked on with this, the designer, knew a whole lot about building full-size outdoor vehicles. And he taught me through a lot of the things about the spacing and the angles and what's required. But at any rate, this vehicle can climb over things that are larger than the diameter of its wheels. Because the front, because of the suspension, moves the wheels up and down while they're driven by the ones that have a better contact with the ground. So that's a lot of work to actually build your own chassis. However, I believe it works markedly better than an unsuspended outdoor vehicle.
For reference scale, what's the diameter of those tires?
Well, let's see. Let me go get a ruler and I will measure them. I will unpresent here.
Yeah, no, I totally agree that having a suspension would be a lot better, but it's a lot more work designing and building it than it is just attaching the wheels to the motors. At this point, I'm going for kind of a quick and dirty.
That's why we're a robot builders club, robot builders night out.
The contest is in August.
Those are 5-inch wheels.
5-inch. So yeah, the building's fine, but I want to get it running and programming it and making it work. So
I just want to play music. I don't want to have to learn all those scales and arpeggios and all that.
Exactly.
Well, the one thing, I mean, there's alternatives. If you look at the rocker bogie, that's quite a complicated system to build with the differential and everything. And so one of the things that kind of turned me on to the idea of possibly building a Mars rover was the idea that the ExoMars doesn't use a rocker bogie. They use 3 rockers, but the rockers aren't that hard. They're just 3, arms that are on bearings. So you don't have any differential at all. It's just 3 rockers. So if you want either a 4 or a 6, actually, I don't think it would work with 4, but if you want a 6-wheel arrangement that doesn't have a suspension but can still climb over things, that triple rocker or triple bogie, I think it's
bogey. That's what they call it. Triple bogey.
A triple bogie arrangement gives you, without suspension, a pretty navigable, 6-wheel drive robot. So that's actually why I'm building one. I wasn't going to try to do the differential. I thought that seemed like a lot of trouble. And I didn't want to do what David's done with the spring suspension, which obviously for David and for anybody would work really well. But I was trying to simplify as well, Ted. And my simplification was to go with the triple bogie. I always forget which one it is. Because that's just 3 bearings and 3 arms. It's not so hard.
Yeah, before you started talking about it, I had never heard of the triple bogie. And yeah, I like that idea.
So where's the bogey come from in this context? Because I've been looking, I use the word, I understand kind of what it means, but I mean, most of these things have an origin. So, and I don't understand bogey. I don't understand.
Harold, that's from train, from the construction of train.
Okay.
The bogey is the pivot thing where the wheels can move up and down separate from the.
Wow, learned something. I knew that thing had a name, but I wouldn't know what it was.
I'd rather it was something Humphrey Bogart determined, but I don't think it did.
Now, just to clarify for those who don't know, the triple bogie on the ExoMars, the European Space Agency robot, has 2 side bogies, and then the one in the back is a side-to-side bogie, and they don't have any connections between the bogies at all. They're all independent and on their own rockers. I mean, they're on their own rockers, yeah. And we actually, apparently, according to Carl, have the presentation of that coming up pretty soon.
Yeah, those guys will be on May 8th.
Yeah.
Is that our next meeting?
Yes.
Yes.
And who are these guys?
They're younger researchers and developers who are on the ExoMars team, and then subsequently decided they would make that little ExoMi robot, the little 3D printed robot that uses the same triple bogie structure. I had contacted them after someone on this list had posted a link to their Harold had posted a link to the ExoMi robot. So I basically just contacted them, and then Maximilian, I think his name is that right, Carl?
I think so. Yeah, Maximilian Earhart and Miro V something.
Yeah, Maximilian got back to me in an email, and we had a little back and forth, and then I told him that we'd be really happy to host having him come and chat, and he said he'd be quite happy to do so and to defend their use of ROS and then discuss anything on what they had done with that little ExoMi robot. And I thought, well, that's great. So They seem like young, friendly, eager to discuss people. So I'm looking forward to seeing what they've got.
This group could use the young part.
Yeah, my wife, what my wife refers to this evening as? This is your grumpy old man meeting tonight, isn't it? That's what my wife calls this group. So
I didn't think of myself as that old, really, but I might be grumpy.
yeah, grumpy for sure. All of them.
Carl, can you put that link in the chat?
Yes, I'll get that for the 8th of May. Yeah.
So far, the grumpiness doesn't seem to be coming through, but I haven't been around long enough.
Well, thank you. That's comforting to hear. But, yeah.
Oh, Murray, you might also look up skateboard motors for electric skateboards. They have hub motors for that too.
Wow.
Cool. That would be a better size. Thanks.
Yeah.
Although at this point, I'm kind of hoping part of the thing is with the motors is that I really want to have encoders, and Servo City sells quite a variety, as do Pololu, a variety of motors that have encoders already built on the back of them. So if I was to use like a skateboard motor or anything like that, I'd have to figure out how to put an encoder on the back of it. And I'd rather have it all built in as one with 6 wires coming off the back. It's a lot easier.
Well, if you wanted to, Murray, if you wanted to pursue it though, there are, even if you have a non-censored not brush, synchronous motor, they're basically synchronous motors. If you have a non-brush synchronous motor, you can buy RC components that will allow you to measure the pulses, and they use the Hall effect sensors that are already in those type of motors that manage the phase difference. So in theory, it wouldn't be real hard to know how many, how much it's turning. Though, like I say, if you're trying to do this by August, everything you get like that's new is going to be another obstacle. One thing about Ted now, he's got himself, then the next step for him is, even if he doesn't perfect the chassis, if he moves on to figure out how to get it to go from point A to point B, that being probably two different things. There's probably some odometry involved in it, and probably some GPS. The sooner you can get onto those particular tasks, the better off he'll be. Just saying. I mean, yeah, you might not take first prize this time, but if your robot can literally get from point A to point B, even if it's doing it by kind of jerking around and bouncing up in the air and whatnot, you're still better off than if you can take some time to do a little obstacle avoidance and a little bit about what do you do when you finally get to the cone.
Ted, we used to have an award that we gave to anybody who actually could just bring a robot and turn it on. because we all know getting to that stage is not trivial.
Oh, yeah.
So you deserve at least a gold star.
Well, I hope I'm not coming across negative. I'm saying Ted has now liberated himself to go on and tackle the next problem. Don't worry. If you saw it move around in the grass.
Yeah. Yep. That's 90. That's 90.
Move on to the next step.
I think this is This is not Ted's first outing with the robot, right?
Oh yeah, no. I competed in the SparkFun AVC and did well in that. So
yeah, and so you got but getting those other parts of it are going to how they are. They're going to be.
So did you have any prizes for generating smoke?
There should be.
And Doug, just to clarify, I'm not trying to get this Mars rover done by August. I mean, I'm effectively designing a robot that's
really?
3 robots in one.
They have a nice design. I mean, I'd love to see one of them. I mean, if you got somebody with a 3D printer, all it takes is the 3D printer and money. I mean, they use servo motors, and there's 12 of them. And about the best you can get is the servo motors is $20. So, you know, you can figure out what that without it, that's not talking about any other parts. You know, that's just the steering servos and the continuous rotation servos that they're using for motors.
But that you're talking about the ExoMi robot, right?
Yeah, I'm
Yeah,
just
well,
saying.
I'm not building one of those, though.
Yeah.
I'm
Yeah.
doing one.
Murray, another thing, and you may already know this, that those systems that are designed around rocker bogies, in order to climb over things, which is really the reason that you go to all that mechanical trouble, basically have to change their geometry. And the way that's accomplished is that when the front wheels run into something, they basically have to stop, and the front wheels continue driving forward, and that's what causes it to rotate and climb over something. And what that means, if you back away from it and kind of throw your eyes out of focus, is that they can only travel slowly.
Understood. Yes. Yeah. No. Yes, I did understand that.
Yeah,
These are
and
not fast robots.
That switching between those two modes takes a period of time, and you can't really slam into anything. You have to kind of creep up to everything. We'll say when we designed the JBot, we spent about a year looking at all the various designs that were out there, and we looked at the rocker bogies real carefully. We looked at, you guys remember those little 6-wheel skid steer duck boats that hunters would take out?
Mhm.
Oh yeah.
Okay. Those were the closest we could
drove
find.
those things.
Yeah, exactly. Those are the closest we could find to what we were wanting to do, but they didn't have independent suspension. In fact, we could find no skid steer vehicles that had independent suspension. And our first take on it was maybe it doesn't work. Maybe that's why none of them have it, because it shoves the wheels around. So we did some modeling and we convinced ourselves that it'll probably work. Let's go ahead and build one. And it actually works remarkably well. That picture I showed of it spinning in place on the floor, it'll do that on gravel or on big heavy rocks. It will make that, you know, with the wheels going up and down, but basically hold the center in that same position. So I haven't, one guy out in California built one, but everybody else thinks it's too much work.
Mm-hmm. So you have a CV joint in each one of those, right?
Yes. And you know, those CV joints and the drives, if you buy just the stock parts, those are plastic. And they're designed for a low torque, high speed radio controlled car. And what we have is just the opposite. We have a high torque, low speed robot. And those, after the first month of use, those just twisted up like pretzels. And so I had to go and replace those. You can buy aftermarket steel CV joints. And so that thing's got, I don't know, $150 worth of steel CV joints on it. But the ones that, as I say, those things are designed to go 35 miles an hour. You know, they're not designed to have a lot of torque. And what we need with robotics is we need low speed and high torque.
Right, and they're designed to brake so that when you hit something, they brake instead of the motor.
Oh, I thought you were going to say they're designed to break so you can have a mechanic fix them.
That too.
Well, I'll tell you, Ted, the guy, Mike Hamilton, he's passed away now, but that was the designer. He used to work for Traxxas. He designed a lot of their cars.
Oh, cool.
He's the one who designed JBot. And he told me that the hardest part of his job was after he built a prototype and they'd run all the tests, and the last thing they did was they did destructive testing. He said he couldn't do it. He'd give the transmitter to somebody else, and they crank the thing up to 40 miles an hour and slam it into a concrete wall so they can then take it apart and find out, you know, if we'd spent 3 more cents on this port here, it wouldn't have broken. You know?
There
But
you
he
go.
said he just couldn't do it after putting his heart and soul into it.
Yeah, my brother spent his whole career, and the term for that person is called a failure technician. Like
I always thought that was my own term.
Yeah, he learned electron microscopy, and when, like, in fact, like, the 2 examples was some American general was golfing and swung the club, and the tip came off and hit someone and killed somebody. So they had to look at the golf club to see why it had broken. And then anytime a military helicopter would crash in California, he was often the one to look at the broken metal. So that's the kind of thing he was doing. Anything broken. Seems like
I'm really good at that job. Every day I learn 2 or 3 different ways not to do something.
And my dad did that for U.S. Steel except it was for bridges basically. So it was bridges, and then there was this one case. I think he showed me the slide at one time that there's a giant barge on Lake Erie. It's a big inland body of water, and the pilot of the barge had apparently backed it into the ice. So it kind of snapped the rudder shaft, but the rudder shaft on that barge was basically like 1 or 2 feet in diameter of steel, and it snapped it. So they had to pull it up, and he had to help him show that it wasn't U.S. Steel's fault. It was because the guy backed the barge into the ice.
It's not a problem I normally have.
No, not normally. But talk about heavy industry. That was wild stuff, right? So, giant pieces of iron and steel, and here we are with these tiny little parts you can't even see. Actually, I was up there a couple of years ago, and he took me to one of his welding society meetings, and there's the Liberty Bridge in Pittsburgh. If you're familiar with the town, if you watch Led Zeppelin, the Swan Song movie, they come out of the tunnel at the very start. They come out of the Liberty Tubes, and they go across the Liberty Bridge. Anyhow, it's this big old bridge. Pittsburgh is a city of bridges, and they had a case 10 years ago or whatever where some construction stuff underneath the bridge caught fire. And it got hot enough that it was melting and weakening the members on the bridge. So they finally managed to put it out. And then there's all this talk that, just another couple of hours and that bridge would have gone down. But then they had to repair it, right? So they showed how they brought in all these teams. They had all these different universities try and model the load on the bridge because there's this giant pieces of multi-foot wide and foot thick pieces of iron and steel that would hold the bridge up, and they kind of melted and twisted. So they had to show how they had to solicit 1,200 or 12 million, whatever, these giant jacks to kind of spread it apart a little bit and then put the beams in place. And it was a pretty wild process to repair a bridge after something like that. But they did it. I still drive over it. It hasn't crashed yet.
I think that's why drive shafts on trucks and cars, well, at least rear-wheel drive cars, are hollow. Because if you have a solid steel shaft, it tends to basically shear off, whereas the tube can take more of that, constant varying torque as each piston fires. There's more torque and less torque. Some of the energy is transmitted into a flywheel, but eventually the drive shaft has to absorb a lot of that.
Is it
because
solid,
it tends to fail quicker?
Is it because the hollow drive shaft can flex slightly, and so you don't have metal fatigue?
Yeah, I think so. Yeah, it can twist over the whole length, whereas you try to do that with something solid, it tends to metal fatigue and shear.
Well, what also would be happening is that on a solid drive shaft, as the shaft is absorbing those shocks, it's effectively being case hardened. So the whole shaft would gradually get harder and harder until it became brittle.
Yeah.
So on another note,
class is accurate.
On another note, we were talking about the continuous drive servos a moment ago, and I thought I had read somewhere that they take more battery power than the brushed and brushless motors. Does anybody have any experience in that?
Say that again.
I thought that the servos, the continuous drive servos, I thought I had read that they eat up the batteries faster than a regular motor. Anybody have any experience?
They are pretty, they're pretty straightforward in the sense that the amount of current they change doesn't change. If you look at their transfer function, otherwise speed versus setting, and you'll see that it goes from essentially full off to full on with a very, very steep transfer center in the middle. And maybe they might have like, 10 millivolts on both sides for a deadband in the middle. But it's very hard with it, especially if you don't have any PID, to go any speed other than 0 or full. Okay, now it is possible to get on the transfer curve, but you really have to work at it. So those motors are either going on, they're just the way they work. Because what happens is how a continuous servo was, it's just like a servo, but the reference is the actual location has been disconnected. So as soon as you put go any direction, any speed, it never gets there. That's why it continuously rotates. Also, the fact that they've taken the plug out that stops the rotation angle. So it just keeps going, and it never satisfies the condition. It's the same control board, though. Am I making sense here?
Right. My question though was about battery usage.
What I'm saying is whatever they're rated at, that's what you're gonna get.
Okay.
I mean, it's at the end of the day, it's just a gear motor in a different package with a different interface for controlling it. Now, are they less efficient than other gear motors? I mean, maybe a little bit, right? I mean, they're not brushless for sure. There are smaller motors, so I suppose they're not the most efficient motors in there. But
yeah, but Chris, on the other hand, these little motors, the micro metal gear motors that Polo sells, as far as I understand, they were actually developed for servos. I think that's where they're originally from.
Yeah, but that's probably a much higher class servo than a standard size, black box servo. Usually the thing that people look for in servo is stability. Otherwise, if you set it at some point and it goes to it, it stays there. And the second thing is the speed that it took to get there, which is usually talked about in milliseconds per 60-degree angle. Otherwise, if you tell it to change 60 degrees, how long does it take to get there?
Sure, but
those
Doug,
are usually your key ones.
But these motors come in probably 20 or 30 different gear ratios. So.
Oh yeah.
Doug, I can't imagine it really makes any difference. As Chris said, basically what you're doing is you take a normal survey and you pull the pot out of it, the potentiometer, which is what keeps it from rotating continuously. And the signal that you use to drive it, basically there's a square wave that's generated by the pot, and it's compared to the square wave that you're sending it, and it drives it either forward or backwards. There's a little bit of dent on there in the middle, which is that very sharp curve. So that's why Doug was saying you basically have to drive it full speed forward or reverse. There's a little bit of play in the middle, but basically it's just you're using the servo because it's an easy way to get a little gearhead motor, and you don't have to use a motor controller. You can just send it a digital signal. So that's the reason for using it.
Right.
I can't imagine that the battery consumption would be any different than any other small gearhead motor.
Yeah. And the fact that it's such a small motor too. I mean, it is a really rinky-dink motor.
I built a couple of robots in the long ago, in the last millennia, and that used those, and real quickly moved on to just straight DC gearhead motors with encoders on them as more flexible and easier to control and everything.
Yeah, you just don't get enough RPM out of those continuous servos, right? I mean, they're convenient, but you just get no RPM.
Yeah, they're slow.
Typically, those things will turn 60 RPMs, typically. And that's what you get. If you, doesn't matter, that's the rating, 60 RPMs, full speed, usually. Because like David, I built my first robots, used those as the motors. Okay. In fact, the first couple, I actually modified a standard servo. Then I found parallax servos, and I started using those because they're much more stable. And because another problem with them is the 0 point depends on the temperature of the motor. So if you're really running something, that 0 point will shift slightly. So you end up with this point where they turn a little bit instead of being completely stopped. Now, the ones that are made to be continuous servo usually have a bigger deadband around 0, and therefore they do a little better job.
I generally found it was just easier to go down to Tanner's and sort through their boxes of DC gearhead motors and wait.
Can't do that no more.
Just as an update, though, Ted had suggested looking at these skateboard motors, and they come in a hub style and a belt drive style. And the belt drive style looks very promising. They come in lots of different sizes, and I'm sure that they're obviously really torquey because they can move a person around. And I think they even have kind of a little bogey arrangement on the left or right, so they can rock because it's a skateboard. So they have basically a frame, a motor, and either a hub or a belt drive, and the belt drive would have its own advantages and disadvantages. But it's thanks, Ted. That's a good. I mean, it's a little bigger still than I'm thinking, and I don't get encoders out of it. But it's they look like a good solid motor for a robot. Be really good.
Was there anyone else in the queue to present, or y'all just general discussion right now?
Oh, go ahead, John.
But before you go ahead, Murray, put that link in the chat.
Oh, I don't have a particular link. If you search on skateboard hub motor or just skateboard motor, you'll get lots of stuff.
I thought you were looking at something.
I'm looking at dozens and dozens of them. I just did skateboard motor, and there's
I can do my own searches.
A whole new industry apparently.
Okay.
Well, the other thing is we call it scooter motors. Similar thing. They're a little bigger and made for scooters, obviously.
Yeah.
Well, we can let John go.
You mentioned the little Pololu gearhead motors, and that's actually what I'm using right now. Some of you might some of you might remember me from about 1.5 years ago. I presented my Halloween robot spider. I remember a few of you here.
Yeah.
And I think, I'd said at the time that I'd wanted to modify the design because I wasn't real happy with the performance of the stepper motors I was using. So now I'm prototyping a spider leg. The real trick is getting some kind of torque out to the outer knuckle, and I was doing that with essentially a bow line and stepper motor, the 12-volt stepper motor. But I've recently designed these essentially as a linear actuator with a worm gear in the middle. That's driven by the little 12-volt gearhead motor from Pololu. They're pretty strong, but I'm still working on this. Hopefully, I'll have an improved spider here by next Halloween. So yeah, I've added the little encoders that they also sell to the back of there. Also have built my own PCV manufactured through Oshpark. It's got an I2C interface for controlling each motor.
John, make it move. Can you make it move for us?
Oh, I'm sorry. It would take me a minute to get everything set up.
How about just with your hands? Can you make the joints move with your hand?
No, because that worm gear in the middle. Yeah, that worm gear in the middle has got it fixed. It's got a. Well, actually, come to think of it, maybe I can.
You don't have to break it for us. But.
Don't let the smoke out.
Well, just to follow up on John's point, though, is that the Pololu motors come in both a low power, medium power, and a high power. And the high power, at the limit of what they do, it's a 35 RPM, 1,000 to 1 gear ratio on a little motor this big that can come with a extended shaft and an encoder on the back. So, the torque on that is like 140 ounce-inches on a little tiny motor. It's pretty impressive.
You have to be careful though, Murray. Make sure you look at the Pololu website. they will have a line somewhere on that page that says that
Don't
they
stall.
don't recommend going above this particular torque limit.
Yeah.
Sure.
Just strip
Okay.
those little gears
So
right off.
they do sell motors with that if you took them to their spec, they would strip out.
Oh,
John,
sure.
can you hold it a little
You
higher?
just have to look at it. A little higher, John. Oh, good.
Oh, cool.
Cool.
So where did you get the worm and the worm gear from? Is it like stock drive products or?
Oh, John, you're muted.
Oh.
John, we don't have your audio.
I'm sorry, I had the audio muted. The worm gear I designed in Fusion 360, and I 3D design and print everything because I'm really not good at metalworking. I don't have the tools for it, so I have the 3D printer, so I do as much in the 3D printing as I possibly can.
So 100% infill or 50%?
All of that's 60% infill. Time will tell if I've got enough strength in there to survive the real action. I'm using the PETG ink, which is pretty strong. I wouldn't use the ABS or PLA for that. It's just not strong enough for the work I'm doing.
When you just moved the leg, were you pulling on the bow wire there? How were you making it move?
Well, that's the point. Is the reason I went with these motors is I can actually embed the motor in the leg segment, all right? And I don't have to run a bow line out anymore to the outer knuckle. The problem with the bow line is, well, first off, the stepper motor really still wasn't powerful enough to pull that bow line to operate the outer knuckle. And, it tended to slip, and I had to maintain enough tension. Had trouble maintaining the tension on the line. So I figured, you know what, I'll try this and see if this will work. This will work better.
Another possible source that you can look at for worm gears and gears is the Vex IQ, which is their plastic models. They sell little kits of extra parts, and they do. I've actually used it on a XY plotter that used Vex motors and worm gears, and they were tremendously geared down, and they did a fantastic job of repetitively positioning the pin. So I'm just saying but I don't think they're very expensive, and they're ABS, by the way.
Yeah, well, the other project I've got going here, if I might present, because I kind of wanted to get some tips, maybe from somebody who's messing with the same sort of thing. What happened to my, this is the first time I've used Google Meet, so.
If you go to the bottom of the screen, there should be a bar that pops up.
Yeah, no, but I'm trying to present a window, but I'm not seeing.
You have to click in the actual window.
I know, but I'm not seeing the windows that. Well, let me go full screen then, because I can't. For some reason, it's not showing the image. Okay, so entire screen. Still not showing it. Let's go. Whoops.
There we go.
There it goes.
Let's see. Which screen are you seeing? Do you see?
It looks like a screensaver.
Mandelbrot set.
Oh, that's the wrong screen. Hang on. Stop sharing. Present now. Entire screen on this screen, screen 1. Now
we're seeing you.
Can you see that?
Looks like you have a camera in a box.
Yep, that is. I'm putting a security camera on my street. It's based on a Raspberry Pi Zero and the Articam 12 megapixel HQ camera.
Nice camera.
And that box is all 3D printed. 3D designed, 3D printed. What I'm running into is I'm using the Motion software. They just call it Motion, that you can download on your Pi from Linux to detect motion. And I'm using OpenALPR to try to read license plates. Have any of you here used OpenALPR?
No.
Well, I'm not surprised because my recent investigations, every time I go look for documentation on it, it's practically non-existent. It appears to be it's free, but it's very poorly documented, and it looks like it's probably an abandoned project. But from what I can tell, it's under the hood. It's based on OpenCV and uses something called Tesseract to do the character recognition, and it doesn't really perform that well at this point in terms of detecting and reading license plates. And I'm thinking I may try to go to a different package. One of the reasons for using OpenALPR is there's practically no learning curve at all to use it. So some of you here must have done optical character recognition on a Pi or under Linux. Do you have any advice there?
I haven't used it, but Pi image search, I think he's got a couple tutorials on specifically that, character recognition for trying to figure out license plates and stuff like that. So it's PY.
Yeah, I've hit that. I've actually hit that website several times. I'm just wondering, if anybody had specific recommendations. But
well, there is a little bit of advice I could possibly give, and that is that there's effectively two modes of license plate registration. And one of them is designed for when cars are parked at a gas station and the car is not moving, and they just take a single JPEG of that and then use that. Whereas the ones that are designed for moving cars have algorithms to take the smear that comes out of the multiple JPEGs that are in an MPEG and be able to take, let's say, 6 or 7 frames and push the smear together. And then from because the car's moving pretty fast, so the actual individual JPEGs will have a bit of a blur to them. And so there's an algorithm that's designed to take multiple JPEGs, and from that whole, the actual numbers out of that set of frames. And if you're talking about moving cars, particularly moving cars at speed across the camera, you probably need some kind of an algorithm like that, which is possibly what this OpenAL, whatever it was that you pointed me at.
Oh, yeah, OpenALPR.
Yeah. And that company, having looked at it, is a commercial company that probably had its marketing department decide that they would do a release into open source to promote their idea that they were open. But as you found out, they haven't been maintaining that at all over the years. So
let's see if I can show you. You mentioned smearing, and what I've actually done is, let's see if I can bring up. There it is. I've got it on a web page. The way I've eliminated the smearing is I've basically just gone to set the shutter speed on for the digital shutter speed on the camera as fast as it'll go under the given conditions. So even though I got a car moving, let's see if I can pick a good one here. Let's pick that one. Can you see that?
Mm-hmm.
So you can see there's not a lot of motion smearing there.
But you're talking at day. A lot of these systems are designed to run 24/7, even at night. So,
right. And here's another one. Yeah, and that's the other thing is I've got infrared. I've got an infrared module that I built myself to light it up at night, and I'm still working on getting enough power to do that, and still getting enough of an exposure to.
That's a pretty bright light if you're going to shine it on cars that are going down the road.
Oh, but you ought to see that. I mean, the thing about license plates is most of the license plates are designed to reflect infrared.
Mm-hmm.
So let's see if I can go to find a night picture here.
Yeah, if you've ever gotten a ticket and gone to court like I have, they show you those photographs, and your license plate is the only thing you can see often on the image.
And a very surprised look on your face, like as that light flashed at you. You know.
Let's see if I can find a good one that shows up, that shows you how bright the license plate is.
I bet they use the same kind of crystals you'll find in like the 3M safety band on shoes and in vests, where it's basically a whole bunch of little corner cube reflectors. So no matter what angle the light comes in, it bounces straight back.
Yep.
Well, I'm not. Let's see. I know there's a few good ones in here somewhere. This just looks like, oh well, you know, that's the lights that are illuminating the license plate.
That's
But
the Popo's license plate.
You know, a few of these you can see that even with. That's not a good one. I mean, when it lights it up, you can tell. Let's see. Keep going.
Maybe I didn't catch it. Did you say why you're doing this?
Well, because I want to be able to catch package thieves. You know, you get all these people stealing packages or thefts in the neighborhood, and the problem is they all rely on Ring cameras, and the Ring cameras aren't, you know, they're pointing out straight out from the door. So most of those thieves don't get caught because, you know, they're going to be wearing a hood or a mask, and even if they weren't, you know, finding them just by recognizing their face is practically impossible. But if I got an image of a car that was in the neighborhood at that time, here's a good example. You see how bright that plate is?
Yep.
That's reflection from the infrared module.
Did you ever hear of glitter bombs?
Glitter bombs.
Oh yeah. What's his name? Rover? Mark Rover?
Yeah.
Yeah, that's pretty entertaining.
I heard that was fake, but it's a fun thing to watch.
The other thing they do is if you own a cat, it's a good way to get rid of kitty litter. Is you open your Amazon box from the bottom, fill it up, close it up, and put it on your porch.
It's like the old garbage strike in New York City. You know, you could
Exactly.
put a present in the back seat, or the back, you know, the back of your truck, and you could
Put all-
get rid of your garbage that way.
Put all your garbage in a box and put a big ribbon and bow on it and leave it unlocked in the back seat of your car.
That's right.
Well, with the windows down, so it doesn't get smashed.
Yeah. So anyway, I've already contacted the local police department, and they're interested. Says if I'll share some of my images, you know, so they'll keep my phone number in case they need to call.
So, John, you think you can do it from just a single image based on what Murray was describing, rather than trying to dig out some kind of character recognition across a number of images that might themselves be mirrored?
Well, that's actually what I'm doing now. What Motion does is I have Motion configured to capture still images. Right now, I'm running it at about 3 frames per second. Motion runs a stream continuously, and based on your configuration, you can say, well, at this frame rate, I want you to get me a frame every, you know, twice, 2 or 3 times a second from that stream, and that's what Motion is giving me. But as what I don't see his name. What's your name from New Zealand?
Murray.
Murray. What Murray pointed out was that, you know, there's a different technique where you can average from a stream of images but I assume that's at a very high frame rate. Now, one of the problems is it's all based on a Pi 0, and a Pi 0 which simply will not, it simply won't perform if you set the image to any appreciable size and try to get a frame rate anything above 2 or 3.
Yeah.
So,
I mean, one of the things about the Pi camera is that the Pi camera is optimized for actually either getting MPEGs or streams of JPEGs. But as you know, the Pi 0 is a single core Pi. It's the only single core Pi that's available now. So even if you went to the Pi, I think it's called the 3A plus. It's this one.
Or B plus.
It's the A plus. That's actually a 4-core, half a gig of memory. So it's got less memory than the B plus, the 3B plus, but it's in a form factor that's kind of unusual. But it's actually got a 4-core processor, whereas the 0W has a single core, so you can't do any you're using the same core for running the Pi as you are for capturing an image.
By the
Whereas-
way, I did leave out some details there for sake of brevity, but in fact, I'm not running the license plate reader software on the Pi Zero.
Oh.
My web server is a Pi 4. It puts up the web server and does the license plate detection software. The Pi Zero, it takes something like 20 to 30 seconds just to do a single image to do license plate reading. And that was just building up this huge queue that was just too much. And so I moved that part to a Pi 4. But there was a lot of design constraints with this. For one thing, it's got a Pi Zero in there, and that box is completely closed. And during the summer, I'm not sure if it's going to survive the heat, but if I put a Pi 3 or a Pi 4 in there, it definitely would.
Too hot. Yeah.
So we'll see what, I've one of the bits of software that I have in there is to read every 10 minutes is to check the temperature on the CPU. So we'll see if it survives the summer heat.
How are you powering it?
I bought a 12-volt landscape lighting transformer, and I run a landscape wire out to the mailbox. And inside the box, I have one of those Pololu step-down regulators to go from 12 volts to 5 volts for the Pi. I hooked that right into the Pi's rail.
Now, John, you are aware that you don't need any hardware or software on a Pi to get the CPU temperature, that there's actually a file that's native to the operating system that's constantly written, and you just read that file. It'd be like 37,163 would be 37 degrees.
Yeah,
it's a
that's what I
5-digit.
meant. Yeah, I'm using software on the Pi to read the CPU temperature.
Just from that file, right?
Yeah, well, I don't know if it's a file. It's something called GenVC.
Oh.
There's some utility on the Pi that you can use to get the CPU temperature.
Oh, well, you don't even, all I'm saying is that you don't even need that. If you read the content of this file, it's a single line that just has a 5-digit number that is the temperature. So.
Oh, okay. Well, that's another option.
Yeah.
John, I don't know if this is of any value to you, but I had a number of years ago set up a little security camera outside my office door, and it was running about what you're describing. I could run on the order of 3 frames per second. And basically what I did was I had since I'm looking at the hallway and it doesn't change very much, I had just a reference frame, and then I would diff that reference frame with whatever the current frame was, looking for the difference to just be larger than some absolute magnitude. And if it was, that's what I declared as motion was detected. And let's see if I can present. I have a little video here.
Actually, what you just described that you did by hand, I won't say by hand, but you wrote the software yourself to do the comparison. That's exactly what motion does, the motion application. And you can set the threshold that says, if this number of pixels has changed, go ahead and trigger that as motion.
Do you see a picture of the hallway outside of my office?
Yeah, I got that.
Okay, so I'm the only one that knows that it's taking a picture every 3 seconds, but I was capturing, you can see what else goes on in the hallway while I'm not there. And there's me.
Yeah, okay.
But basically, how do I get out of this? Stop
sharing.
Stop sharing. Yeah. Was just doing a sample by sample. It just looked to see is each sample, within some range of the same sample in the reference frame. The larger problem of de-blurring things when they're moving is kind of a generalized case of like what the astronomers do with speckled interferometry, where you have a whole bunch of images and the photon is zooming down through the atmosphere and getting disturbed as it does. And by taking a whole bunch of those, you can go back and basically get a higher resolution image than any of the individual images allow. And there's bound to be, probably even OpenCV has a package to do that. It's very common thing to do when you have a big data set with a lot of noisy data.
Okay. Well, yeah, I wouldn't, the problem I have there is that, you know, the maximum number of frames per second I'm going to get right now out of the Pi Zero is somewhere around 2 or 3 frames per second. So what you're talking about would have to be, especially on a moving car.
Now that's true. That's true.
Would have to be a very high frame rate to be able to do that. So
Looks like your images are very
for the
clear.
suggestion.
Didn't really see that much smearing at all. I mean, you know, it looked like you could easily recognize the numbers on the plates.
Yeah, and you saw how dark the image was at night. That's because I've got the shutter speed. Basically, I'm going to saddle point there. I've got it just fast enough to pick up the license plate without image smearing, without motion smearing. So, but I'm not interested in the rest of the car. I'm just interested in the plate.
And I assume because we can look at those and we can read them as humans, there must be enough information there for an algorithm to read also.
Yeah, and I think one of the limitations of OpenALPR is they've got training data that's on a per country basis. But I'm wondering, you know, they got one set of data for all the US. Now, if I had training data that was just for Texas, I probably could get a lot better results because it doesn't have to go through a lot of different fonts from different states to figure out which particular character this is. But
I'm thinking there's probably some open source data sets somewhere, because this is not I bet this problem has been solved in an open source way. So I bet there's a large either data set out there or a TensorFlow or an Onyx model just sitting out there waiting to be able to say, hey, I know these plates, very similar to what you're doing already, but specifically for Texas plates. It's a gut feeling. It just seems like it should be there already. But
I did know that when I drive through the tollway, the camera there that takes a picture of my license plate does so by doing a huge burst of light as I drive by.
Yeah. Well, that was one of my design constraints is I definitely did not want to interfere with traffic on the street. So that's why I've got, you know, that infrared module on there, which I'm waiting for more parts now. I'm going to double the illumination once those parts come in.
Plus, your criminals may not be all Texans. You know, they may be, you know.
Well, they could, but you know,
but still, probably coming from Oklahoma.
Well,
yeah.
I thought that was the only place that had criminals.
Yeah, the idea is to get, you know, even if you tailored it for Texas, the idea is to get enough of an accuracy rate. You know, hey, I don't mind dropping a few out-of-state plates as long as I get a large percentage of the Texas plates. I'm happy.
Keep us posted on how this works. I find it interesting.
So one of the other things I'm doing right now that I just implemented is I want to be able to enter a plate to search for. And because the OCR is so-so in terms of accuracy, I'm using something called the Levenstein distance. Does anybody know what that is? It's Levenstein distance is the number of single character edits that you can perform on one string, the shortest number of edits you can perform on one string to reach another string. So if you got 2 strings that are 7 characters long and 2 of the characters in one string are different from the 2 in the other, that's a Levenstein distance of 2. And I've modified that to where what I'm doing is I'm recording I'm going in to the data that I'm collecting, and I'll read the plate myself and enter that information. And so later I can gather those statistics and go, well, which characters does this algorithm, this open ALPR tend to get wrong more than others? So for example, it has a real hard time with the letter K for some reason, but it doesn't have nearly as much of a problem with the letter J. So by gathering all of these statistics on which characters are interpreted more accurately than others, What I'm doing is I'm going in and modifying this Levenstein distance algorithm to say, well, it counts a one character edit as the value of 1 always, the default algorithm. What I'm doing is I'm going in and saying, well, if this character, if the character J, let me give an example. The character 8 tends to get interpreted as an uppercase B fairly often. Then if the difference is between if the different character is an 8 and a B, I'll say that Levenstein distance isn't 1. I'm going to make that very small. I'm going to make that like 0.1 based on the statistics that I have. So instead of getting an integer result on the Levenstein distance, I get something that's more tuned for on a character by character basis. So I'm just was prototyping it today, and it works in terms of matching plates. It works a lot better than just the unmodified algorithm.
Hey, John, one thing that I'm kind of coming at the same angle, I think, as maybe Chris is on this, is I'm still a little bit unclear. Like I have, I think 4 or 5 security cameras around my house just in case someone decides to break in. And if someone breaks in and they don't steal the computer that everything's stored on, I'll be okay. But if there was a burglary or something happens in your neighborhood, won't you simply have the images from your camera anyway? Would you need to have this optical character recognition? If something happens on a certain night, you could just go and look at all the images that happened at that certain time.
Well, the goal isn't to actually catch the criminal in the act. The goal is to once a crime is reported, if there's a theft at the end of the block somewhere, then I can go and look at the timestamps of the license plates that it's captured and establish this car was coming through the neighborhood at this time, and that gives the police an additional data point that they can investigate and say, go find out if these are your guys.
Sure, but you don't need to have a optical character recognition for that. You would have the images, right?
That's true. You can, but it's a lot more effort to just go, to go through and sort through images, especially if you're using in this use case I'm talking about, where you say, well, I want to search for a license plate across multiple days of data and see if they ever came through. So instead of having to scroll through all of the images and find it, all right, I can just put in the search plate and have it come up with it immediately.
But you realize that the police will never, ever release to you a license plate of a suspect.
Well, that's why I'm just going to give them access to the link to my website and let them do it themselves.
It reminds me of my days working in video surveillance, and the use case you just described, John, of searching, because we had a system where you could actually sort of you were collecting the data, the metadata, as it's being recorded, right? And then you hope to find it. We had a video surveillance system where you could basically crunch through the recorded video after the fact, right? There are different algorithms. You could just search for motion or motion that meets a certain criteria, right? And other things. But we would reprocess the entire video after the fact, so that, if you don't have that particular type of metadata recorded, you could, you're a little more flexible that way. So in your case, right? So, and to Murray's point, you kind of have all the video, and maybe you record only video when there's motion, which is very standard practice in video surveillance. You record when there's motion, or what was very common in my experience is when there's no motion, you record at like 1 frame a second, just so that you have proof that there's nothing there, because it's also sometimes important, right? Otherwise you won't know, did the video system not work, right? So you record 1 frame a second when there's no motion. When there's motion, you kick it up to 30 frames a second, right? And then, so you could have all that video recorded, like Murray was suggesting, and then post-process it, right? And run it through some algorithms, because the algorithms, chances are they keep changing, right? And so you have the raw data, you can then process it sort of offline, or maybe even on a faster computer, right? Now you don't even have to do this on a Pi. You could just do this on a much faster computer, and maybe you get better accuracy. I don't know, but it's just something to think about. It's a different way of using the data.
Yeah, and one of the reasons for using the Pi 4 is the Pi 4 is the web server and the post processing is I can basically process the data at my leisure. The Pi 4 doesn't even have to be terribly fast, as long as it's a lot faster than the Pi 0, and it is. So that's why I've allocated the license plate recognition to the Pi 4.
But are you keeping any video around, or just sort of the images, or not even images that have license plates in it?
I'm keeping all of basically I'm not keeping any video. I've got motion set up to give me still images when it detects motion. And sometimes there's a misfire, especially on I tell you, when it's a partly cloudy day and there's clouds overhead, and every time a cloud is moving from overhead and the shadows are moving, it's virtually impossible to not count that as motion, I found. So I just tolerate all the extra still images that it captures. But yeah, it's just still images, and all the post processing is allocated to the Pi 4.
So are you keeping the images on the Pi or transmitting them to a network source?
I'm using a Linux utility called rsync to pull the images every 10 minutes, to pull the images off of the Pi 0 onto the Pi 4. So
and speaking to using that motion software, which is what is on the little Octocam you can buy for about $50, and that's what I've got around my house, which is this Motion OS on a Raspberry Pi 0.
Right.
Is that it's almost impossible around here not to be constantly getting images because we have so much wind that all the trees and all the bushes are constantly moving. And you get cloud changes and light changes as well. But my cameras run pretty much the whole time there's light because everything's blowing around so much that all my cameras are constantly pulling in images. I might as well be running MPEGs because the software is not good enough to tune out the motion of bushes and things like that.
You're using Motionize OS?
Yeah.
Yeah, I've seen a lot of references to that. If you just use straight Motion, the Motion app, it's got a lot of tuning parameters in there. I've got it set to where if it's a clear windy day, it hits almost no false triggers because I don't have any big trees that have a big limb moving in front, So if it's just looking down the street, the noise filtering in the Motion software is good enough where it can filter out the small changes from a distance. Even when it's windy, but it can't filter out those huge cloud images that are moving across the street. It'll say, I see a whole bunch of pixels changing. I'm counting that as motion.
Yeah. It's essentially the same algorithm. The problem is that my house is surrounded by trees and I've got a fence around my house with trees, and the motion of the trees and the shadows of the trees and on the fence is just, I'd have to chop all my trees down, which I don't want to do.
Yeah, I can understand that. I didn't want to. I know I'm chewing up a lot of your time now, but it sounds like y'all are very interested.
Good discussion. That's how you can tell.
Hey, I have a question on your illumination. Are you synchronizing the illumination with the flash? I mean,
no. I'm just leaving the infrared on all night.
Can that be a burst of light? It's more like.
I thought about that, but the difficulty in synchronizing the illumination to the
frame,
because I got cars moving in both directions. By the time the motion, you got to have at some point, you've got software that's detecting the motion. Well, you have to be illuminated in order to detect that motion. So it's kind of a chicken and egg there. Now, if I had some other mechanism that could detect, well, let's say if I laid a pneumatic tire detection, I don't know what you call it, pneumatic line out in the street when a tire rolled over it, then that can turn on the illumination. But that's kind of defeating the whole idea of using the motion software in the first place, right? And I'm not going to run anything physical out into the street anyway. That's a little bit just too invasive in terms of my local
This
environment.
is a constant source. Yeah, I'm thinking when I work on this vision application, usually it's like a short burst of light. But anyway, it's about the signal to noise ratio, right? If you have a shutter that's really not collecting much ambient, but collecting your light source. But I guess it's really depending on your hardware whether you have that burst of light source available.
Yeah, once again, I don't want to have any visible light. You know, I want to use infrared because I don't want to interfere with traffic.
Right. Yeah.
The other point is to kind of keep it low key so that it doesn't look like something somebody wants to steal. I've got a little lock on it, you know, a little luggage lock that makes it a little bit harder to take. But as long as it looks like just some sort of custom job and not something you could resell, I don't think many people are going to think of messing with it.
Yeah, the image looks pretty good. I'd say. So whatever you have, it's a good setup.
Yeah, I
Usually,
found that if you go with the standard, I actually went through a phase where I tried to use the standard RPI camera without a lens attached, and the resolution is just not high enough for the license plate detection to work. So I went with I think the standard camera, the version 1.1 of the Raspberry Pi camera is 5 megapixels. The 1.2 is 8. And the high quality camera made by Articam or sold by Articam is 12 megapixels. And that's the one I'm using with a 12 millimeter lens.
Oh, it's not like a CS mount lens. It's just.
It is the high quality camera has a CS mount lens. The Raspberry Pi camera version 1.2, it's just got the little, I don't know what you call it, the little camera module with a tiny lens on it, built in. So yeah, you know, this project had all sorts of design constraints, and one of them is I don't want to basically spend a whole lot of money on the thing to begin with. So you know, why not just buy something off the shelf if you're going to do that? And of course, you won't learn anything, but so I've got the cost of the camera module itself. That whole box is actually somewhere around $185. I calculated. And if you throw in, you know, the landscape transformer and running the wire and Raspberry Pi 4, then the cost goes up closer to $300.
How much of that is the camera?
The camera module, the Articam camera module, high quality camera costs $50 or $60, and the lens, the C-mounted lens that goes with it, that's another $25. So yeah, about $75 of the whole cost is the camera and lens. Okay, somebody else's turn.
Cool. Yeah.
I had a question about your contest coming up in August.
All right, Pat, let's get on to robot contest. What you got?
You guys have piqued my interest, and out of curiosity, I'd just like to share my screen if that's all right.
Please do.
Hang on.
I'll put some links in, by the way, related to the contest in the chat for whoever might want links.
See if I get the right one. So, do you think that would be acceptable as a contest location? Basically a soccer field. I would be looking at putting in obstacles on it as described in your plan.
Yeah, you probably have access to logs, right?
Well, you know, if you need some sort of tree, I got lots of access to logs. Yes, I do. They grow on trees and they're all over the place at work.
Yeah. Maybe some bottles of maple syrup as well, or something. I don't know.
So what I'm thinking of doing is using some
balls.
tents.
What's that?
Using some dome tents to simulate some shrubberies and block the view and that sort of thing. And so I was just curious about the size.
No, I haven't internalized the rules. So who, Doug, can you remember, or has anyone read the rules lately? Does it look like that would fit the dimensional things and
From my reading, well, it's 100 yards, I thought, between the cones.
as a triangle? The longest one's 100 yards, so yeah.
So I'm just going to go back here.
Well, I don't know. In Canada, it's probably so many meters as a soccer field, right?
Yeah. So I don't know if I'm presenting.
You are. Looks good.
Yeah, we see
So that's where I was looking at it as 100 yards, looking at using that distance along the edge of the field, the long edge.
The long edge, and then just.
Yes. And then coming across kitty corner across the field on the two sides to make the challenge cone.
Yep.
You can get a picnic table too. Just
I may be able to find a picnic table.
Yeah, I don't think they'd mind if you planted some trees and shrubs. That'd be okay.
Yeah, they probably would mind if I dig a ditch, though.
Yeah, digging a ditch is probably going to be a problem for them.
Hey, Pat.
Yes.
Can you put your picture back up?
Oh, yeah, sorry.
Is the goal to have a realistic outdoor environment or any obstacles?
Any to me, it's any obstacle I can put in the way. I can't plant trees.
Well, then the easiest thing would probably just be cardboard boxes. Get some big cardboard boxes and weight them down so the wind won't blow them, and that's a cheap way to go. And
We've used.
I own a number of tents.
We've used that before. We just got big washing machine or refrigerator boxes and scattered them around.
Or coolers filled with beer.
Yeah.
So Pat, your course, if I see this right, is a soccer field with a track around it and a border area, right?
Yes.
Okay. So, some examples of what might be something we could, is that somebody's backyard, or can you use those areas that are around the track?
So I don't know if you can see my mouse.
Yep.
Yeah.
There's the edge of the property line.
Okay, so you can use anything. You can use those trees that are. If you bring your mouse straight down, those.
Yes.
You can use those.
Yep.
Well, I'll be quite honest. We're probably if you were to submit this site, what we would do is probably do something like crazy, like start you off in the center of the soccer field and run you over the cross all the way across the. I'd have to check the yardage because I don't remember what a soccer field is, but run you across the track, which looks like it has a curb or a border.
Yeah, it does have a little bit of a curb.
Yeah, and that would also give you different terrains, and then we would probably try to route you through those trees.
Okay.
So
well, that track serve as the ditch in your photo in your example there because of the difference of it's got to be a little up and dip in there, right?
Yeah, to cross the road, there's a dip on both sides, and then it's a gravel track.
Yeah, so that'd be a different surface. So I mean, you could use this. I think we could work it out. I mean, if you got one, if you can get one, we won't tell you exactly, till the day of the contest where the coordinates are.
Yep.
All right, and if you read the rules, you have to have somebody with you.
Yep.
To help you.
This isn't my ideal location as well either, because I'd have to do it all by data on my phone to transmit it or record it ahead of time.
Yeah. Well,
there is enough room, I think, to do it.
Yeah, I think so too. Like I say, we would try to make it as tough on you as we could, but you might need a couple of boxes. So like for, David, we're going to have him drop off. We're going to have it where if you go straight, there's a well and with no protection on it, so that when his robot goes across the well, down in a hole.
30 feet.
Yeah.
I'm just kidding. Yeah, but like you can imagine, it's in this drawing that you're showing right now, it's a nice triangle, okay? And the sides are going to vary in real life. It may not be this nice of a triangle.
Okay.
Okay. It depends on your site. We'll try to make it, the things we'll try to do is give you as much variety in surface that we can. And if you go for the challenge course, some reasonable obstacles, we'd like an obstacle density that you would at least hit one obstacle and ideally 2 or 3. So that you have to navigate them.
Can I bring up a picture?
Yeah.
Sure, I'll stop sharing. So part of my reasoning with using the soccer field area is that if I had to add some obstacles like a picnic table or instead of shrubs, I could plant some trees instead of planting trees. I could plant some tents. Tents are pretty easy. They're hard to see.
This, what David's showing right now, it won't be that bad.
Oh, come on.
The reason will be because we don't have that on our site.
That's the log. You have a log in the drawing. There's the log.
Oh, yeah.
All you need is some beavers. Get some beavers to put the logs in place.
If we had logs like that, we wouldn't be making 2x4s.
Yeah, that's true.
The twigs.
But that's a real nice, I wish I could get that course, David. You know what I mean? That would be fantastic.
Well, it's only a few miles from our cabin up in Colorado.
Are you inviting us all?
Yes. Yes, absolutely.
Yeah.
So you've piqued my interest with the course and being able to do it remotely like this.
Yeah.
It's something that I'm seriously considering.
Right, and remember, if you set your, if you can't do the whole course, do 1 cone. If you can do 1 cone, you can do 2 cones. Okay.
And Pat, the whole reason we have these contests is to encourage people to build robots. Right. So even if your robot can't do exactly what the course is designed for, we don't really care that much. As long as it'll do something, we'll all applaud and give you attaboys and
Yeah.
You only need 1 point to get the mug.
Get a mug, yeah.
Yeah. So
cost you $5 to make the mug and $15 to ship it to Canada.
Do you guys ever pull?
No, don't worry about that. We pay shipping.
Just imagine if we had to ship it to New Zealand.
Yeah. Well, I'm more worried that Murray might get it in pieces, like a little piece here and a little piece there. But no, I mean, they actually pack them up pretty good. They'd probably make it, maybe.
Okay. Well, I've got a practice field right behind my house. It's not big enough to do the contest. It's probably maybe 200 feet long by 70 feet wide.
Yeah. When you see 100 yards for the first time with your robot, when you're sitting there and you see that 100 yards away.
Yep.
God, it looks like forever.
It's light years.
That's why I looked at the soccer field, because you're getting pretty close to 100 yards.
Yeah.
That's a long. It's a long way away for those little motors to go.
Do you guys ever pool your expertise for any of these projects? Like, for example, I've built my own motor driver board with an I2C interface and position feedback for this project. And this is fairly easy for me to do. Anytime anybody needs a specialized driver or interface or whatever, I could do that for someone. And for sure, you guys might have projects that have certain needs. I might have projects that have certain needs. I'm just wondering if y'all ever, it looks like y'all tend to just kind of roll your own.
Yeah, you're right. We tend to roll our own because we're not smart.
Well, it has nothing to do with, I think it has nothing to do with smart. I think it has everything to do with motivation. I didn't know much before I eventually got to building one of these. It's the motivation to learn.
Yeah.
Who makes your boards, John? Are those the Oshkosh or one of those?
Yeah, Oshpark, because I love them because they're like, you can get less than $10 a board for some of these small boards, 3 boards each.
Is that the one that'll also populate it for you if you want?
No, I don't know if they maybe they do, but I don't think they do.
There's some where if you order the parts on their you use their models and their bill of materials, you can order the board and they'll actually solder the parts down for you.
Yeah, but I looked into that and I thought it's difficult. It's more difficult. The more parts you got, the more difficult it is. Yeah, I did look into it, and I know I talked to the guys about running another spin of David's board, and that's probably going to happen sooner or later, but we'll see how it goes. I did manage to get a corrected design from Ron. He had corrected the design. I guess David had given him feedback, so we do have a corrected design. It's just the question is to go ahead and, if you wanted a bare board, we can probably do that pretty quick. But if you want one that's all populated, I don't know if I got the,
Okay.
Yeah.
The hardest thing on those boards is putting those little tiny bypass capacitor surface
Yes,
mount
I
bypass.
know.
Okay, so I have built one of those boards without those little tiny surface mount, and it works fine.
Yeah.
I just thought I'd pass that along.
That's good news. And like I say, they're actually, I've been looking at populating those on my board that you gave me, Dave. And I think that I don't think actually they're not, if you use solder paste, well, I can't say this. I was going to say, if you have, like, I happen to have access to a laser cutter, so cutting a stencil isn't that hard. So smearing the goop or the solder paste on isn't that hard. And I have a oven that I can use, but I don't eat it. And it's actually my powder coating oven. I can put that in there and get that treated. So it's just something that hasn't gotten up to the level for me to go do.
Yeah, I do almost all surface mount now. I've just learned to do the really, really tiny parts, on these surface mount boards with real fine pitch. Basically I try to keep things as small as possible, but they are a pain in the ass to put together, and you definitely better have a microscope.
Yeah, I can hardly see those parts. Those little caps, we did manage. We did what you're describing, Doug. We put the solder paste on the board, and then we floated all those caps on the solder paste and stuck it in a toaster oven. And once the solder paste melts, it kind of centers the part. It kind of floats over into the center. And it was actually, one of the engineers at work actually did it for me. I took it in and I went,
Yeah.
Well, I'm looking at this surface mount ruler that I got from Mauser, and you can definitely buy smaller parts and make the job a lot harder.
I could start that.
So, if you're doing your own designs, I think part of the answer is to use the slightly larger than industry would use,
maybe,
so that you don't have to worry too much about that placement. It wouldn't have made any difference in Ron's board if he'd have gone up one capacitor size.
I gave him
dimensional
because
size.
that board had to fit into a space. And so he basically took up all that space. John, maybe a better answer to your question is there are some of us who do routinely make our own boards. Scott, who's won the can collecting, he builds all his own microprocessor boards, and that's what he does for a living. So it naturally, that's the way he did it.
Yeah.
And I've made a few of them that are mostly just when they're things that I couldn't buy. You know, I needed something special. My philosophy has always been that I'll buy anything, that I only buy things I can't make. I should rephrase that. I only make things that I can't buy, being how life is short and all.
Yeah.
I got some new toys in. I'd like to show off a little bit. Right?
Cool.
We're just talking about this. I'm going to present. I'm going to try to present.
Hey John, have you ever tried to do the equivalent of like the RoboClaw 2-channel 60 amp?
They're asking me.
Yeah.
Oh no, all my stuff is pretty small scale, and a lot of
Oh,
it's based on a microchip PIC.
Ray, is that your own board?
This, God no, this is
God no.
made by.
All right.
It's got a aluminum heatsink on the back and heat.
Can you guys see me?
No.
Not yet.
A RoboClaw 2x60.
Like, that's a robot.
Presenting. Oh,
Yeah.
Yeah, you're not presenting.
Now I am.
No, you're not.
And yeah, I am.
This thing is like $200.
Oh, there we go.
Now you're presenting. Now you're presenting. There you go.
Here, let me make a full screen thing here. Okay, there's me and my mug. This is some of the toys I got over. You can see I got that microscope you guys are talking about. Started playing with that while we've been talking, and this is what the results out of it. I've got to play with the. Give me a white background so you can see it. So it can send you a little card, so you can see how small you can get. Right. So those are all millimeters, 10th of millimeters, and they got a grid over here. That's a 0.1 by a 0.1 grid, so that you can get really small on that stuff and see it. I'm going to have to work with the lights a little bit, that kind of thing, to make it happen. But got it so I can do it on my Twitch stream and get to playing with some of this stuff. I thought it was really, really cool. Line width, 0.3 millimeter. Looks to be real sharp. I've got a nice 1080, like a 1080. I think it's not quite 1080 screen over here, but it's a 7-inch LCD where I can look directly at it. Currently, I've got it in PC mode, so I'll have to look at another screen off to the set while I solder. We'll see how that's going to play out, right? And that sort of thing going on. The other thing that I've been doing, you might hear in the background my 3D printer going off, is I have been printing up my ExoMi stuff. And
you're doing it. You're gonna build one.
Dude, there's the chassis, man.
Oh, way to go.
So let me see if I can get, yeah, you can see the side view of it there a little bit. Here's the front of it. I got the top of it going on there. I've got some of the battery hold downs and a few other things in there, and some pieces and parts. So the outside of this thing goes about like that. I'm going to use the top here, and so it's kind of hard to see the top of it. It's already there, and you just kind of bolt all this stuff together. I still got pieces and parts coming. In fact, I get more coming tomorrow that I didn't expect till Friday. And what I plan on doing with this, they've got a whole bunch of stuff where it shows off solar panels and stuff hanging off of it. So instead of doing all that noise, it's non-functional just for looks. I may use that and throw some other things on it, like the GPS, and probably I've got one of those B&O 55s, 88s, whatever it is, they want to stick on here. And on the very top, I've decided that I have I've got for the Raspberry Pi cam that's supposed to fit up there. They've got like funky, cool things, but I'm going to throw all that away and mount me the camera on a servo so I can pan around and do that sort of thing on it and go to looking. I'm currently printing. If you look right over here, I'm currently printing the back bogey and some of the and a side bogey on it with some tough PLA. First time I'm printing with it, it seems to be printing really well. I like the flat color I'm getting off that. It's kind of hard to say this, but it's purple. We'll see how it actually is supposed to be a little bit more resilient and tough on that. And so it won't break as much or whatever. And I'm going to print the wheels out of some PET G just for the hardness. And they've got some slip covers that I'm going to print out a TPU on that eventually. So that I've got a little gription going on. Things have been printing pretty well. I have me a Raspberry Pi 4 with 8 gigs on it. So that's ready to, I've got the software based on that. The ROS Docker image is on there for their base image. And we're going to see if, and that's what I did Monday night on my Twitch stream. I got some DC buck converters that it's not what they expect, but it's what I could find and what I could get delivered. That we're going to set up the 5-volt, to get easy 5 volts out of this thing. And so I'm in the process of building it all. So
all right,
we'll see how far and how far it goes. What now?
You mentioned tough PLA. How does that compare to just standard PLA?
It's supposed to be, again, this is just what I've read because I've not tried it out anymore. I can tell you I've got some pieces here that these pieces on the piece I have here, it has a little bit more bend to it. And I got a whole bunch of other standard PLL pieces I can dig out of my recycle bin down here that literally snapped when I tried to break the support off of them. This thing did not snap. It actually gave a little bit, and it feels a little rubbery. In fact, this is one of the covers for the wiring for one of the bogies, and it's got a lot of good bend in it. So not so much this way. Of course, this is not supposed to support that way. I'll try it more when I pull that other bogey off.
Is that filament made by a company called M3D?
I have no idea because this is inland filament from Micro Center because I just drive down there, and Micro Center don't make crap themselves, but this is a Micro Center brand. For the longest time, I knew their PLA, just their standard PLA, was eSun. I do not know who makes this for them and who they rebrand it from.
Yeah, I've had a lot of good luck with inland filament.
Yeah, I have
of
too.
them. All of them. All the different weird types.
My first 3D printer I got from M3D. I'm not sure if you're familiar with that company. I think they almost got started as a GoFundMe project or something like that. It was just a little box printer just to play with.
Yeah.
They sold an ink called Tough 3D ink, and I think it was ABS. But the nice thing about it, let's see if I can find a piece right here. I have some sample pieces. Where did I put them? Oh, I can't find it at the moment. But the nice thing about their Tough 3D ink is like what you said. It's more flexible than most of the stuff I print with. All the stuff I print with.
And this may be a good thing or a bad thing that the bogies are out of this Tough 3D. I mean, we're going to play with it and find out, right? As far as the printing goes on this thing with all of this, it's printing just like PLA. The temperature range is 210 to 230 on it, so it's a little hotter than most, because most normal PLAs they're like 195, 200 kind of thing, right? And I've had a lot of good luck with their PLA Plus as well, and that's a little hotter. But this is the high ends edging up into the ABS range of stuff. So
hey, Harold, what are you having to run your hot plate? What do you have to run your bed?
I got it at 60, just like I do with normal PLA.
Oh, that's good.
Ramp it up.
That's one of the worst things about ABS. You got to have that hot plate up a lot hotter than that.
You got to have it way hot, and you notice I've got an enclosure that I built up with. I did a minimalist build on that enclosure. I mean, you can't really see it so much, but let me see if I can get rack around there a little bit. I can do one of no. Come on, I had it where I guess I've changed it.
Did you say you got that Tough PLA from Micro Center?
Micro Center, yeah, they got shelves of it. So it's a little bit hard to see, but if you look at the yellow bits on this, that's the only 3D printed parts. And I used a bunch of Luan and just the drilled holes and use the Luan as a structure to build my enclosure. And when I'm printing ABS, even though it's not sealed up or whatever, it gets to be about at 40, 45 degrees C in that enclosure, so the ABS tends to do very well in there without peeling off the plate.
Yeah, I have a separate printer for ABS that I leave set up that I made. In fact, if you go on in Thingiverse and my name, my email and my Thingiverse name are the same. It's Paradoug. I've actually got where it uses a piece of it uses minimalistic pieces of printed, and it uses foam board for the sides and stuff, except for the front where it's plexiglass. And with an enclosure, ABS is a lot easier, much easier.
Harold, is that tough 3D? Is that 1.75 or 2.8?
Yep, 1.75. I don't, I have never used a printer that uses 3 millimeters. I've only ever, or the 285 that the Ultramakers use. I've only ever used 175.
I kind of regret getting a 2.85 millimeter printer because it's just so much harder to find filament.
Yeah.
Yeah.
Yeah. And I like the purple. I mean, I don't know how it comes. I think my white balance is pretty bad on my camera, so you can't tell it's purple. But it's kind of got this flat, textured look to it that on the printed part when it's done, I'm kind of digging that. By the way, as far as colors, and my wheels are going to be orangish, Pet G. So I'm going to have, I got white chassis and purple bogies and oranges, and going to have black TPU running on them. So I'm going to be a colorful thing. And since it's only running ROS 1 on it, but it's a Docker. I've already fired it up. It works. So we'll see how much I need to expand on that to do various bits and pieces. And I've got something to do, unfortunately, on the 8th at 11. Hopefully I'm done enough so when I'm driving back home, I can jump on the 1 o'clock meeting with the XOMI guys. I've joined up to their Discord and said hello. They said hello, or somebody said hello back. I don't know if it was them or not. But there's only a couple hundred people on that Discord thing doing stuff. So out of the whole world, I think it's going to be kind of fun, and playing with stuff. And
sounds like you'll have model number 22 or 23.
Maybe so.
Yeah.
So, and I intend, one of the reasons I sprang for the 8 gigabyte Pi instead of the 4 gig, and I've got a heatsink and that's one of the things they don't spec on this. They have a servo board you plant right on the Pi, and that doesn't leave room for a heat sink on the 4B. I will tell you right now, yes, you can run a 4B and it will not blow up without a heat sink, but after a few minutes you get throttled, so you might as well be running an A. It just throttles everything down to nothing. And so I've got a heat sink with a pair of dual fans on another Pi. I've ordered the same basic thing coming for this, and Adafruit. Oh yeah, look, Adafruit's killing it. If you go look, I'll go find the thing real fast and find it. Adafruit has some new boards out that you folks may want to take advantage of. Let me go get to the new products. Come on. Oh yeah, here's an example of one of them, and I will put it into the so everybody can see, and then go back to seeing you guys. What that thing is that I just put in the chat is a right angle GPIO standoff board that connects to a 40-pin ribbon cable that will connect to another one of those, so you can run that 40-pin flexible ribbon cable anywhere you want to, then plug in your board again on it. So it's just basically where you can shift the pins in a sane way. And so now I'm going to put a heat sink on top of it, and then I was just going to add some extra long stackers, but instead of that, I'm going to have to change the internal of this just a little bit to move that servo board off center and get it away so I can got plenty of cooling going on the Pi.
Yeah,
And
but
I'm
didn't they make that for the Pi 400?
the Pi 400 works. Yeah.
Yeah.
I don't know if they made it necessarily for the Pi 400, but they recognize that people are putting heat sinks on their Pi 4Bs, and now they can't plug in most of their hats, and so they're giving it so they're making those things. I'm like, that was a great idea.
Harold, is that a problem you've actually seen, the overheating of that board?
Yes. When I got my first Pi 4 that I put on my donkey car, and I was doing some playing with it with throwing on Ross, and it was fast, and then I say it fast. It seemed to be just sluggish, like I was running in mud. And then I went and touched it, like I touched the Ethernet port, and I'm like, yikes! That is not no, we're doing that. I mean, literally, you could not touch it for very long at all. And so I'm like, okay, let me go get the HS, the heatsink fan on there, and it's a dual. It's not one of the big stand up tall ones. It's just flat, sits on the top of it, got a couple of fans blowing on it all the time, and it's going to use more juice, those fans, because they're blowing on it all the time. But my Raspberry Pi 4 does not throttle. Yeah, there you go. I don't have as big a heat sink as Doug does, but the dual fan setup is very similar to what I have. Exactly.
Yeah.
And it makes a tremendous amount of difference going and just and it not slowing down on you.
What did you say you were using the TPU for? And what were the characteristics of TPU that you needed for that?
What now? The TPU. What happens is the first design of this ExoMi, it says print these wheels, and these wheels are okay with running over like gravelly kind of things and that kind of stuff, because they've got some paddles, bumps on them, act as paddles to move things forward. But one of the guys says, well, I run this on a smooth floor every now and then, and so those paddles end up slipping and they don't have any grip on it. So they modeled up some sleeves that'll sleeve on top of that, and I'm going to use TPU to print those sleeves up and then put them on each one of the wheels. So it will help me have more. I believe it will help me have more traction as I go.
So basically, the TPU is more flexible, and that will give you more grip.
It's like Ninja Flex.
It's Ninja Flex. Ninja Flex is the brand name for that. TPU is the generic name for all that stuff, but Ninja Flex is a particular brand of it.
And the inline works really good. It's good stuff.
Yeah.
And Harold, the one thing you have to do to make sure is you need to cut your retraction. You have to set your retraction to 0. So that means you're going to have a little bit of whispering.
Yeah, I'm good with that. I'm good with that. I've got hot air guns and everything else to take care of that. And me and my wife, unfortunately, over the past 2 years, have both lost our wedding rings. And so, for various circumstances, we have.
Oh, you just froze up.
I thought he was going to say that he 3D printed some wedding rings.
No, but I think it's highly suspicious. Just as he got ready to tell us, it froze. I wonder, Harold, where is your wife right now?
My wife is somewhere else. I had something happen. I don't know what it is. But anyway, we both lost our wedding rings and we haven't replaced them for various reasons. And so I got sitting around watching some of these ads where, like, because sometimes wearing a ring while you're doing some industrial work is a bad idea because something gets caught on it and rip your finger off, right?
Mm-hmm.
So there's these rubberized rings. They want $40 a piece for them. I'm like, well, hell, I got some TPU stuff sitting on the shelf I've never used, and I can model up a couple of rings. If I can't model up a couple of rings by now, what the hell? And so I modeled up one that has like a little dip in it for me, and her, she has some things that got 2 or 3 things in a row right there, and I made a hole through it to fit her fingers. And so I printed, I don't know, half a dozen of these TPU rings because and they came out really good, and it's very small. These tires, on the other hand, are going to be significantly bigger. So yeah, so they say 100% infill, and they say no retraction, and so that's going to be something I get to learn on that kind of stuff.
I gotta
Hey, Harold,
say,
I want to know, did she go for the purple or for the orange?
I know we're all white. We're all white. That's the only TPU I have right now. So
I gotta say, Harold, for anyone whose wife has a 3D printed ring, you are the king of nerds.
no, we're bragging about it. And we just went to a wedding, and they're bragging about there, and they said, "No, that's so cool," and they all think it's cool. And so,
okay, Doug, what the heck is whispering?
Do what now? What, Ray?
Oh, I was asking Doug, what is whispering? I've never heard that term with 3D.
That might not be the official. It's little, thin, very, very, very. Looks like a hair that grows out of your 3D print.
Yeah, they call it stranding.
Huh?
Stranding.
Stringing.
Yeah, stringing. I've heard stringing.
Yeah.
Stringing, I think, is the official term.
I like whispering. I'm gonna.
Yeah, I mean, they just like little whispers of filament,
oh.
And it happens because your retraction is not set right. But with these NinjaFlex type materials, you can't back up inside of your extruder, or you lose the fox.
Yeah, I have in preparation. This a long time ago. I got a Bowden tube set up, not a direct drive, which is generally it's more harder to print the flexible filament. I have upgraded my Bowden tube to some of that Capricorn, really, really slick tubing, and it does a really good job on the rings. We'll see how the little stuff works really well. We'll see how well it works on the bigger stuff as it goes. Yeah.
Well, I have a robot question.
Okay.
If that's allowed.
No, you know me. I got robots thing. I'm
only
ADD.
if your robot asks it.
Yeah. Don't get Murray started talking about his garden.
Hey, wait a minute. Before we go any further, it's been, what is it? It's 10:05 and 10:06 by my record.
Pid loops. No, this was a question for Chris. Last week, he was working on a remote sensor. And have you made any more progress on that, or decided how you want to proceed?
I have. I can show that real quick. So let me a little pointy stick here so I can move the camera. Don't get motion sick. All right. So for those who weren't on the call last week, I have a QTR line sensor down here, and I'll turn it upside down in a moment. And I had a bunch of wires clogging up all the space up here, preventing me from putting sensors, and that's the front of the robot, right? So all these wires were going right into here, right? So the issue was I had no space left for sensors. So I took the cutie pie as I was talking about it. Now, I kind of chickened out on sort of permanently, attaching it to the line sensor array and soldering real short wires. I kind of decided to keep my options open, right? So I kind of kept the original, somewhat oversized wires that come out of the QTR in place. Decided to go with connectors on the cutie pie, and I realized that I kind of have enough headroom. I kind of have enough ground clearance down here, and it may not come across well, but I have enough ground clearance down here, so I can just stick that cutie pie onto the battery compartment. I can still open that, get to the batteries again. So that way, I just didn't have to, I didn't want to. Yeah, I like to keep my options open, so I just went with the route of not sort of making this an integral part of the line sensor array. So it's done. There's the power and I2C coming. I know this is not in focus. Power and I2C coming, through this, Adafruit sort of SparkFun connector thing here, going into my I2C bus. I still have the option of using the USB connection, so that would give me the virtual serial port, and I am planning to go into the Raspberry Pi with that, right? So I can reprogram my Qt Pi, and I bought this little USB-C male connectors, so I can make my own, short, flexible cable. This has the 4 essential signals broken out, which again, you probably can't see very well here, but it's just power ground and data plus, data minus is really all you care about. I don't care about any of the other USB signals, and these connectors, don't even bring them out. So the point is, again, I can make very short and flexible custom USB cables, with the other end looking something like this.
Chris, where did you get those power connectors from?
This connector?
Yep.
So it's not a power connector. This is a USB-C male connector. It doesn't carry just power. It carries power plus data. But it doesn't carry the new USB-C data signals, all the extra signals that are part of USB 3.0. It carries just the legacy data plus and data minus. So 4 pins in total, just like, on the other end, this has 4 pins, right? Data, VCC, and, power, ground, and differential data. I got it from, this is just Amazon, and they have a couple different ones. It was a little hard to find. It's still a little bigger than it has to be, right? It still sticks out quite a bit, but it is what it is. You can buy them on DigiKey as well if you wanted to get even more bare bones. But this is what I found on Amazon, like $1 a piece. Get a pack of 6 or 5. So there's a number of things nowadays come with USB-C sort of female connectors, right? So the Qt Pi, what else? My little green board I/O expansion thingy, also has USB-C on it, and so these little guys are a little harder to come by. You're not going to get as many choices as with some of the other USB connectors, but they're out there. Oh yeah, okay?
Chris, just to be clear, there's already one of those plugged into the Qt Pi, right?
Well, correct. I've already plugged one in, so you can see it's kind of sticking out a little more than it really needs to. But they're all kind of a fairly, okay, maybe lying correct. They're all sort of the standard size.
This is regular USB. You can get these on Adcore. You may be able to find ones like that on Adcore, ADDICOR.
Yeah, the regular ones, I mean, again, they're like a dime a dozen, right, on Amazon. So I have a bag full of these. That's not a problem. And even USB micro. Where I didn't see as many choices is in the USB-C variety. Again, this is male USB-C. So there I didn't see as many choices, and they're a bit more expensive. I mean, they're like a $1.20 each versus 25 cents each for the other USB connectors.
Hey Chris, if you could put a link in, that would really be good. If you could look on your Amazon account and see the link to where.
Yeah, I'll do that. So this is working. Again, this is going into the same I2C bus that the Romy control board is also connected to, and I can pull the data out. So again, the Qt Pi, I just turned it into an I2C, A to D converter. And one of these wires is for PWM output, so I can control the brightness of the IR LEDs, and everything else is the analog input. So every pin of this board is now used up. 8 analog, 2 I2C, 1 PWM, and that's it.
Chris, again, to clarify, so looking down from this perspective on the Qt Pi, the signals coming in from the left and right are all the standards. Those are the cables you thought last week you might clip off, and
that's correct. Those are the cables that I thought about clipping off, but then I decided not butchering this existing wiring harness and
and just going with some connectors here. Again, in the end, it's still very bulky, but I had the room underneath here, so I didn't care about the bulk. And it's all very flat, right? The QT Py is very flat. I mean, it doesn't really take away of my ground clearance too much.
That has a lot of room. So the wires in the signal then are power and the I2C bus, and that's how you'll actually operate the thing. And then the USB mini C connector is for programming.
Yeah,
so
that's right. This will be for programming. Unless I find issues with I2C, then I could just use that as a virtual serial port, right? So I kind of have two options for getting the data out. Right now I use the I2C coming over this standard quick wire there. But I can also use the serial port that you get with this USB connection as a debug port, or even just to pump the data out. Right? I'm kind of a bit on the fence that I just go all I2C or go all USB UART sort of to all my slave devices.
But the way you're envisioning it now, there won't be when it's running, there won't be anything connected to the USB port.
I think I will have it permanently connected just because I can, with making my sort of custom cables with a little bit of ribbon cable there. It's going to be very flexible and just the right length so it doesn't get in the way. So I do plan on having it connected. But you're right, technically I don't need to because I am getting power. I am getting power right here. 3.3 volts. So on this is the standard, Adafruit Quick or SparkFun, SparkFun Quick. Adafruit calls it something else, QT, right? Carries 3.3 volts. So I had to modify the lens sensor array so that it knows it expects 3.3 volts. Haven't tried it out yet to see if it performs the same way as before, but I hope it will. And so yeah, so this keeps everything above now very clean. Now, apart from giving me room for the sensors, I now have freed up a bunch of inputs on my Romy control board, and so which technically I don't need this guy right now. I could technically do all those obstacle avoidance sensors with the Romy control board. So I have to sort of still decide what I want to do there, but I have 6 or 7 inputs here, 6 analog inputs free now, and there's probably 1 or 2 digital inputs that I can find somewhere on here. But right now I'm just going a bit in circles on exactly what component of sensors I want. It's sometimes I find it hard to make these decisions, right? Because I'm trying to decide should I put 3 forward-facing ultrasonics here, and then maybe an IR sensor sort of facing at an angle to the side, or just one ultrasonic and a total of 4 IR sensors, 2 of them forward facing and then maybe 2 of them side facing, right? So I'm kind of going in circles on the exact arrangement of sensors. I just have to make a decision and do it.
Oh, more is always better.
Yeah.
If it's of any use, that's similar to the setup that I have on the 2-wheel balancing robot. But let me grab it.
I was going to say you can do what Dave or Murray do. Put every sensor on there that you
I don't know if you can see here, but basically there are 2 of those sonar sensors that's facing forward there. And then you see underneath those are the 2 slightly outward facing IR sensors.
Right.
And for this particular one, there is another IR sensor in the center right at the bottom because it can't see anything down here. But I have found that coverage, you look in from the top, you can see maybe the offset of the...
Yeah.
Okay, and that was enough coverage for me to be able to navigate without running into anything.
So what made you decide to kind of angle your ultrasonics outward like that?
Well, basically the sensors I use are pretty much always in pairs. And the information that's most interesting is if a detection is on the left or on the right. Because if it's on the left, you can turn right, and if it's on the right, you can turn left. If it's in the center, it's not so obvious what to do. So it invites some creativity. But basically, by tipping them left and right like that, you have three separate zones. You have a left zone, a center zone, and a right zone. The center zone just overlaps just a little bit.
Okay.
Well,
Yeah, I mean, the one thing, as you can see, I don't have a ton of space here. It's just, the ultrasonic sensors are a bit more bulky than the IR sensors, and so that's why lately I've been thinking, maybe I should just have more of these guys on here. They just use up a lot less space.
Yeah, but they only give you a single point out there.
That's the issue, exactly. That's why I think I want the ultrasonic.
The sonar gives you a beam.
Right.
So in that sense, I think it's interesting when I read on the net, people always offer that as a disadvantage. Oh no, you don't want the sonar. The beam is too wide. You want a little tiny narrow beam. And that might be true for some applications, but for general obstacle detection and avoidance, you want a wide beam so that you don't miss anything.
Right.
Well, just to clarify, though, is that I'm using, I think, the same ones as Chris, which is the analog sensors, the infrared analog sensors, which actually aren't quite as narrow as that. At I think about 500, half a meter. I think the spread is about probably 10 centimeters.
Murray, I actually have a infrared night vision scope, and I've looked at those. I know exactly what they look like. They send it. It's not actually just a little beam. It's not like the older Sharp, which were just a single laser point. These they actually send through a little holographic, lens, and it spreads it out into a little thing that looks remarkably like a window, a box with an X in the middle of it, and that then gets larger as you get further away.
Right.
And it effectively sets how far away those can see. The ones that I have can see out to about 6 feet, and by that time the window is maybe 3 or 4 inches side. But still, for any normal navigation, if you tried to just use those, they would miss a whole lot of things.
No, I'm not disagreeing. I was just clarifying because on the front of my robot, I've got one in the center, 2 oblique, and then I've got the ones on the side, and I'm using those. The coverage. I've kind of, as you said, the spread on those. I've tried to have the oblique ones at only a slight angle off center, so that there's mostly coverage. And of course, as you send out further and further, that spreads the angle of them spreads out. But I'm not trying to locate things that are a long way from the robot. These are, even though as you said, about 6 feet, they're supposed to go 1.5 meters. They don't really. They go about maybe 1 meter, maybe a little bit more.
Yeah, I was going to ask about the 6 feet, David. Which ones are those? Because the ones I have,
let me go
some
read.
of them, this one will go for 1.5 meters, 10 centimeters to 150.
Let me go read the actual part number.
But the point is, though, is that you're not really trying to avoid something that's a meter away. I'm using those to try to avoid hitting something that might be, a short distance away from the robot. Now, the only point I wanted to add was that the center one I'm using differently, and that is as the robot is driving forward towards something, I want to be able to have the robot slow down as it gets nearer to it. So I'm actually spending a little more effort on that center one to determine how far the robot is, let's say, from a wall. Whereas the oblique ones are more for just avoidance, and the side ones are for wall following. But I think that David's point with the ultrasonics is well taken. And in fact, a few weeks ago, I had contacted the company that sells those ultrasonic sensors from, I think, in Texas. I can't remember where it was, but they're quite a lot more complicated to set up than the cheap ones, but they're certainly better. But I kind of look at these, the analog infrareds, not so much as anything more than obstacle avoidance for close range, even though their range is like over 1 meter. Because as David pointed out, the spread is so far that by the time you get 1 meter away, that you've got a giant hole between them.
Chris, those are it's a Sharp I'll put it in the chat. It's a GP2Y0A60SZLF, which has a distance out to about 150 centimeters. Is that the one you were talking about?
That must be similar to what I'm talking about. The one I've got, it's 10 centimeters to 150. Those are more recent ones. And I got a bag full of the older ones that are 4 to 30 inches, so whatever that is in centimeters. But you know, the more recent models, you know, for this 10 to 150 centimeters, I have an older version of this that's much bulkier. Right?
Yes, I remember those. It had a great big lens on it.
Yeah. I have one of those too.
Yeah, exactly. No, these, but these are the ones that I was talking about, looking through the night vision and seeing the pattern.
Yeah. I did have one announcement, which I'll probably announce next week when there's more people still around. Carl is aware, and a few other people are aware, is that I started a Discord server for personal robotics. And I think, Chris, you've joined up as far as I can see. And the idea being that there's actually, Discord is a relatively recent gamer-based chat server, and it's getting really, really popular. As Harold noted, ExoMi has got one, Pimoroni's got one, there's a Raspberry Pi.
I got one too.
You got one too. Well, I've got one called Personal Robotics, and I put a post into the mailing list about how to join, and anybody's welcome. The idea is that it's a place where you can come on and discuss hardware, software, and have a chat rather than email, which is a whole different thing than email. It's not meant to replace a mailing list at all. It's a little more immediate because it's not quite synchronous, but kind of synchronous. You really should be online at the same time as somebody else. But I've been finding the Unexpected Maker one, which is Sean. I'm not sure how you pronounce his name. He's an Australian guy that makes the ESP32 boards, the Tiny Pico and the Feather S2. He created an Unexpected Maker channel or a server. And so I decided, well, why not give it a try, since there actually wasn't one for personal robotics already. There's a bunch of commercial ones for the different robot challenges and things, but there didn't seem to be a robotics one, so I just went ahead and made it. It doesn't cost anything, but anybody's welcome. And apart from that, like I said, I'll announce that earlier on in the video conference next week if I'm around, just because I missed Pat. I was kind of trying to get a hold of Pat before he left.
And one of the nice things is, unless you have a really big group, you know, or you want to use some of the extra features, it's free.
Yeah.
I set up a Discord server. I've done a little gaming, online gaming with some friends, and it's like, wow, this is easy, cheap, free. I mean,
yeah. I'm not sure what their business model is, but yeah, there's not even any advertising.
I think
somebody earlier was talking about attracting younger crowds to this DPRG session, and I think this could be one way to help do it, right? Because it's a kind of a tool that those that haven't retired yet are maybe using.
I think the way they make their money is essentially what they do is they kind of suck you in, and then you go, oh, here's some of the nicer features you can use if you pay, right? So if you're just a basic user, you know, and that's all you want to do, then it's free, and they just basically just add the features that you might want to pay for.
Yeah, because pretty much if you're a basic user, you know, you got a couple of, you know, you may get, I don't know, a few hundred people using it, and it's sporadic and all that kind of stuff. So it really doesn't cost them that much. If you get to be a bigger user and you want to use the tools, then, you know, they get the $5 to $10 a month kind of thing to get some more stuff to make you able to manage your, you know, thousands and thousands and hundreds of thousands of fans that want to be on your Discord server. Right.
Yeah.
So I agree with you, John. I believe that's how they make their money.
Well, just to give you an idea, is that in order to sign up for what they call discovery, so you can show up sort of in their whole their universe, you have to have at least 7,000 members. So this is designed for the gamer community, where there's probably hundreds of thousands of members on some of those boards. But for, you know, it's nice though that I can create a server. I don't have to be just a user. I can actually create a server and host effectively a community. And it doesn't cost me anything. So that's nice. In any case, I encourage anybody to join that wants to. In terms of news, I have been successful in my robot operating system. I've been trying to build an asynchronous message bus, and that's now largely functional. And I've added an arbitrator and a controller in there now. And the challenge was to make it into a project that could be installed using standard Python 3 tools like Pip3, and which means that you post it to PyPy, which is a standard distribution hub for Python software. And I've managed to do that as well onto their test server. So once I've got this to a point where I'm happy with it, I can do a version 1 and post it onto PyPy, and then it becomes like a standard sudo pip3 install in the name of my project, and it will just come onto your Linux box or whatever that is. It does run without a robot right now. It's actually designed to run on a laptop, and you can just type in keys that simulate the robot sensors. So the idea is that if the infrared center or oblique on my robot has a sense, it would normally send a message or an event, and you can just type those. It's the idea is that I can test this out and see how the asynchronous message bus would react, and I can then run mock behaviors based on the sensors. The idea being that you don't actually have to have a robot to get this thing up and running. And the project is now on GitHub. It's called, I've decided I can't call it Ross anymore. I have to come up with a new name. So it's called, because my two robots are the KR01 and the KD01, those are my K-series robots, so I'm calling it KROS or Cross. So the new project is Cross-Core, and that's the logging, YAML configuration, message bus, subsumption hardware. If you downloaded that, you'd have the sort of basis of a robot operating system. That's kind of the idea. So that's just about ready. And apart from that, one visual, I have this now up and running. It's not running, I should say, but I've started to prototype the actual 1/6 of a robot. And this is just a temporary wheel. I'm actually trying to come up with a way to build the wheels from scratch, which looks to be using a Servo City disc that they sell with looks to be either stainless, 100 mil stainless tubing, or maybe plastic. I'm not sure, like a PVC pipe. But just building wheels and building the armature and all that's really tricky. I don't have a real shop. Like a metal shop would be lovely, but I don't have that. In any case, the real announcement was the Discord server, and Carl, you're also, by the way, an administrator now.
Oh, thanks. Okay, cool. I'll help if I can.
Well, the idea is that I don't want to say that I own that. It's really kind of a cooperative ownership on the Personal Robotics Discord server, so that we can cooperatively work on it and invite people and see if we can get it off the ground. The whole trick on that, of course, is getting enough people to get a quorum and get it going, I think.
Get a critical mass started.
Yeah.
One of the difficulties I found though with Discord is, depending on the person's microphone gain, whatever, I have had quite a few problems getting their volume to come out right. But they do have a volume. You can change the volume per user that you hear on your side. So you might run into a little bit of that you have to toy with.
So
I've been mostly focusing on the text side of things. So I know they do video and all that, but for me, it's mostly just text.
That's what I was thinking too. Are you using it more for the speaking part, John?
Well, if you're gaming, yeah, you're going to be, in a voice channel with somebody else. So if you're just doing text with it, yeah, you don't have to mess with that.
Yeah, I don't know that we'd be sharing any robot screens quite yet. Maybe Doug D will eventually be sharing robot screens.
Yeah, I mean, if you want to use it just like you use Zoom or like you use Google Meet, you can do that too, and it's still free.
Yeah.
Now, I haven't tried to see how well it scales with video and voice, with more users. The most I've ever gotten on a Discord channel was maybe 4 people.
Yeah, that's what when we use it for family game night, that's how it is. And that's California, Chicago, San Diego, Chicago, and Dallas.
Wow, got the country.
Well, and Baltimore, and it worked out okay.
Wow. Well, guys, hey, it was nice to meet you. I don't know if you know this, and I just joined DPRG, even though I presented a year and a half ago with that robot spider.
Welcome.
So nice meeting you all again, or if I haven't met you before, nice meeting you for the first time.
Keep us posted on that camera business.
Well, it's definitely a work in progress, and I'm gonna have to wait until July to get the infrared LEDs that I ordered. So once I can boost the infrared power, hopefully I'll get better night performance.
Carl, are we done?
I'm looking around. I'm not sure. Has anyone else got anything to raise?
Mr. Big Head.
No.
Turn that up to 11.
Yeah, Mr. Big Head says turn it up to 11, baby. Let's go.
Yeah. So I think we're good. I'm quiet tonight. So you guys have a great evening. We'll catch you next Tuesday night.
Yeah.
Hey, John,
Yes.
before you drop off,